In your head, please take the number 10. No, don't laugh at me.
Go ahead, laugh at it.
I practiced. So how many people have it so far? All right, good. I'm quitting while I'm ahead. Take half of that number, then multiply it by 7. Add 1. How many people have a 2-digit number? Take the sum of those 2 digits. And then take 1/3 of that. No, don't take 1/3 of it. Take 2/3 of it. And then take that number and find it on the clock. There's a clock back there. Yeah. And go 180 degrees around the clock. It doesn't matter. I'll give you a hint. It doesn't matter whether you go clockwise or counterclockwise. You get the same number. All right. And how many people have a 2-digit number now? How many people? That narrows it down on the clock. All right. Raise your hand if you have an answer, please. What do you have, please?
12.
Tara?
12.
How many people have 13? How many people think she didn't say 13? But she could have if it was a baker's dozen. How many people think she said 12? How many people agree with that? Who remembers what number I started with? Just holler it out. 10. I'll take a hand. What did I do to that? Take a hand for that. What did I do to that 10? Anybody remember? Hand. That's not Ken, I'm pretty sure. Cindy. Everybody half of 10 is? 5. Anybody remember what I did to that? 5? By 7? Everybody 5 times 7? 35. And then add 1? 36. And there's some weird directions on that one. This way or this way? The sum, on your fingers, please, the sum of the digits in 36. I know you were going to try and do it with a 3 and a 6, huh, but it didn't work. Yeah. How many people agree with 9? And then, let's see, 9. Not 1/3, but 2/3? 2/3 of 9 is, everybody? 6. And, hey, I know what comes next. How many people think if you went 180 degrees clockwise or counterclockwise on the clock, you'd get to 12? Very nice.
How many people think 1/2 is greater? How many people think 9/17 is greater? Who could get me started on an argument about how you came to that conclusion without whipping out your cell phone calculator, doodad?
Just started?
Just started.
Okay, I like that.
Just started. I like these hands up already. Let's go with Jenny.
I have my kids look at the relationship between the numerator.
Wait, Jenny.
I have my kids look at the relationship between the numerator and denominator, and if they could make, you want me to say it?
How many people know why I'm pausing her right here? How many people think she's just starting the argument? Thank you, Jenny. Now I'm going to see if somebody can take over. She said something about a relationship. Anybody take it from there? Take it from there. Take it from there. Cindy.
And as they're looking at the relationship between the 9 and the 17, I asked them, okay, what is half of 17?
What's half of 17, everybody? How many people think 9 is larger than 8.5? So 8.5/17 is exactly a half? How many people think 8.5/17 would be exactly a half? How many people think that's kind of a weird fraction? But how many people think it's useful? All right, cool. So we got that one. 7 over question mark has got to be between 0 and 1. Let's see. I'm trying to figure out how to do a show on fingers question. Show me a number that is one edge of the numbers that could be there on your fingers. Show me one of the possible values, and it might be on the extreme end of the set of numbers that could possibly be there. So I am seeing mostly 8s. How many people agree if I had 7 8s, that would fall between 0 and 1? And would the numbers that would also be applicable, would they be greater or less than 8? How many people think they'd be greater? All right, cool. Good. Good. So we're going to pause and do a mini debrief right now. How many people remember after we did the problem about 5x5 square and the checkerboard that we did a debriefing of the lesson after that last week. How many people recall that? Yeah, so we got half of our agenda over here, and we got half of our agenda over there, because we're trying to write large enough for everyone to see. All right, so we just did day 2 in the head problem, and now we're going to debrief that a little bit, just like we'll do later. After we do the problem with stairs, we're going to have a debriefing after that, where we make the teaching transparent. So similar kind of structure. How many people were not here last week? All right, so this is good that I'm going over this. Okay, and then we're going to do some more math that's kind of more like some procedures that we have to teach about the number line and fractions. We're going to continue from where we were last week, taking a look at some more stuff. And then we get to eat. Pardon me. How many people are happy to eat? Yeah, it's good. There's still food back there. You can keep at it. I don't know when they take it away, but they will, so make sure you keep grazing. All right. Let's see. A debriefing thing. I remember when Rick was doing that head problem, he was funny. How many people remember that? That he was funny. Now I want to ask you a question about that. There was a time when, oh, sorry, my notes, and I'm teaching, I'm having trouble. At the very beginning, he hadn't even given you a step, and he said, how many people have it so far? How many people remember that? There were no steps, right? There was nothing in our heads yet, and we laughed. I'm suggesting that's actually an instructional strategy. What did Rick know when the whole room laughed at that joke? How many people agree with that? All right, I heard a bunch of people say listening. So then you guys were not going to miss the first step, right? Because you got you listening. So you can use humor in a way that actually helps you out. Does anybody think of any other ways he might have used humor during that time frame where it actually gave him some information about how everybody was processing? That's tricky. Here I am, I just had you get a head problem, and now we're trying to get you to think about, from the teacher's point of view, that thing. Anybody remember something like that that happened that was funny? Yeah. I got a hand over here from Liz. I'm coming with the mic, Liz. Sorry.
When he asked us about the number 13 being on the clock.
How many people remember that? I missed that. What did he say about that? Did you guys laugh at that? Oh, how many people agree the number 13 is not on the clock? All right. And so did he know you were kind of knowing what was going on and what the deal was there because you knew 13 wasn't on the clock and that wasn't where you were at, yeah? Okay. Any other examples where humor was actually part of what was helping us get together on the math? All right. Well, let me ask you this. Modes of response. He had you raise hands. He had you laugh. What else did he? What was this? Jazz hands? Oh, I didn't let the camera hear you.
Show a number on our fingers.
Nice job, Cynthia. Yeah, there was a play when he was replaying the head problem. He went through the head problem one time, and then he got to a place that was maybe where anybody that wasn't like me, wasn't quite listening. You guys all showed on your fingers where you were at, and if I wasn't listening and I saw all you guys show on your fingers, what does that do for me that if I missed a few steps? Right? So I could look at, so that's one good thing. So if I was a person that wasn't, I just walked in the door or I didn't catch it, I could get caught up right there. Does that also give Rick some information and some feedback about what everybody knows in the room? So those are, so modes of response, I'm thinking about that. Raising hands, laughter, showing fingers. I don't know, what else did we do? Anybody think of any, was that pretty much it so far? Okay, well so you can be watching today for more modes of response. We'll bring that up. And I'll be revealing. Did we talk about MIFF last time? Okay, so how many people agree we did not reveal all those letters yet? All right, so puzzles. There's one on my back, too. I will write this that's on my back. It's another puzzle. So we'll be revealing. You can be watching for MIFF. I have to steal a marker. So I think I'm gonna quit with the debrief unless Carrie or Rick have another thing that we should say for the mini debrief.
Oh, I do want...
Good, you have another thing?
I did want to ask one thing. How many people remember in that head problem like kind of a misstated question and then restated? Could somebody raise a hand and tell me what that was? Yes, thank you. How many people recall that? How many people think that was intentional? I know, after last week you might not, huh? But, you know, it was. Tell me about that. Why well, I'll give you an example of one. I tried to do the same sort of thing in a different, with one of the other groups, where I took a number and I said, double it. No, don't take its double, take one less than its double. What's the purpose of that, like, thinking-wise? Yeah.
Because in your head, by saying that, you're creating a mental picture of a second number, which then you can use to determine the actual question.
How many people agree with that? When you guys yourselves do 2/3 of a number, do you do it at one step or two steps? What's your first step? Hey, that must have been deliberate.
I think so, Rick.
I'm making a comeback.
That's good.
All right, okay.
If you do enough deliberate ones, they won't know when we accidentally do them.
Yeah, I mean, so anyway, so, all right, so we got that. All right, so then let's see. A problem to think about. So sometimes I teach big kids, sometimes I teach little kids. And I've done this for a long time, so I have to preface this a little bit. So like, you know, even 20, 30 years ago, what do you think when I teach like second or third graders, one of the first thing they would notice about me, my appearance? Now remember 20, 30 years ago. How many people think they probably notice that? Well, you know, being tall, I also probably have long legs. Which means, you know, I want you to have some sympathy for me here. I didn't take the elevator this morning.
No, you didn't.
And so little kids, I'll ask them sometimes if there's stairs in the school, what's that very difficult decision I have to make when I walk up the stairs? I'll take a hand for that. Now you may, if you don't have long legs, you may have to use your imagination, but there's a decision I have to make as I walk up those stairs. Does anybody know what that is? I hear a lot of mumbling. Deanna.
How many stairs at a time shall you take?
How many people agree how many stairs at a time? So now there's different ways to approach this problem, but for now, we'll assume my legs aren't hugely long. I can only either take one or two. All right. So suppose, now steps meaning the physical thing, not that's a step. I can either go up two. Yeah, okay. We had this issue last time. All right. So let's see. We'll start off like this. What if there were, you know, 5 steps to go up? How many people think there's more than one path to go up those 5 steps? Can somebody tell me one? One. I'll take a hand for one of them. What's one? Yes.
Every single
Dawn.
step.
How many people agree with that? So that would be how many steps on the first one? 1. And then? 1. And then? 1. And then? So I'm going to write that down up here. I could go 1, 1, 1, 1, 1. Are there others? So I'll take another hand. Somebody give me another one? Melissa.
2, 2, 1.
How many people think that would also work? If it's, how many steps, what's the sum of these numbers? And these numbers? So how many people think I didn't waste, went up, okay, it's perfect. How many people think there's probably more? Any guesses for how many more? A guess. Just a guess. Oh, I know, this is harder because there's cameras, huh?
I will come with the mic.
All right. You can kind of go like this and then they won't see who you are. What? Isn't that what they do? They put that thing over people's, yeah, okay.
You don't know who I am anymore.
I know.
I'm hiding.
Well, only if, never mind. So a guess. Well, all right, how about this as a cautious group? How many people think there are at least 2 ways? 2 total, at least 2. Oh, no. Yeah, we have 2 up there. All right, how many people think there are more? Any guesses for how many more? That's a smaller number, maybe more. Tracy. Oh, I shouldn't have said your name, huh, because now they know.
That's okay. 2, 1, 2.
Oh, that's another one, 2. 2, 1. How many people think there are at least 3 ways? All right, I wonder if we just end up kind of putting all these up and count them up. How many ways? How many think? How many think? A lot. How many people think a lot? How many? This is a tough group this morning. How many people think at least 3? Fewer than 100. All right, go ahead, see if you can list them on your whiteboards, papers, whatever you have, please. Now, you don't have to go to the stairs to do it. Oh, okay, food. Okay, that's okay. All right, sorry. I thought we had a field trip going here. You can go 2 at a time. Can't go 3. You can go at most 2 at a time. Go ahead, sorry.
Or 1.
Or 1, yeah, at most. Yeah.
You have choices, 1 or 2 at a time. So how many people are feeling pretty good about what they have jotted down there for the ways? Was it more than 100? On the count of 3, we can all say how many we got, okay? 1, 2, 3. 8. How many people all think we're in the ballpark? We've got 8s and 9s. Sweet. Okay. Well, let's see. We got 3 of them up here. I'd like to get a list on the board. How many people are willing to help me with that? You help me with the list? So we've got 3 up there. I don't know what makes sense to... Did any of these make you think of others when you were looking at these? How many people thought of others when they looked at some of these? All right, anybody willing to give me what they thought was next? What's another one? What's another one? Oh, I was just standing by you. Stacy, what's your partner's name? You're Stacy? Oh, my bad. I thought that was Stacy over there. Yeah, Stacy.
So 1, 2, 2.
How many people think that makes some sense to put that one up there with the others that are up there? All right, anybody got some more? Some more. That's Katie, right?
1, 1, 2, 1.
I'm gonna get my exercise today. Is it Diana?
Yes. 2, 1, 1, 1.
More? Okay.
Calling people for
I'm actually having fun, but okay, this will be the last one. It's kind of slow.
1, 1, 1, 2.
Am I done? Oh, dagnabbit.
I bet everybody could tell you the next one.
Yeah, could they? Go.
1, 2, 1, 1.
Now are we done? No. Somebody got another one? Another one?
You can't say it just another one because some of them have to.
Oh, I'm sorry. Does someone have another way to go up the stairs in a different order? Was that better stated? I state it in context, right? How many of people are starting to think that this is maybe all of the ways to go up 5 stairs if we can only go up 1 or 2 at a time?
What's a 9th one?
Well, here, I think people have been checking lists. I haven't heard somebody say that they thought there was a 9th one. But perhaps they have changed their minds now, is what I'm suggesting. So let's not do kindergarten cop and go, stranger! So what I'd like you to talk with your tables about is, if you indeed think those are all of them, or if you think there's 3 more, stick your 3 more. My question is, how do you know for sure you got them all? Because maybe you just need a little more time, and a little more food, and a little more coffee. Maybe you just haven't. How many people think we might be able to find another one? Oh, how many people are pretty sure we're not going to find another one? Well, how do you know that for sure, that there can't actually be another one that you can quit looking? That's the question I want you to kind of wrestle with at your tables. Talk at your tables. How do you know for sure?
How many people knew she was going to ask that? So I'm kind of curious. How many people think these why questions are the tougher ones? Okay, and I mean, you know, she wasn't even 8:30 when she asked that. That's pretty brutal. But one of the things that's been coming a lot. Suppose I told you a formula that would give you 8 for an answer. Would that?
Racking a brain over here.
I mean, would that make you more convinced that you had them all? Yeah. Would it? Yeah. Oh, no problem then. I can do that. Huh?
But you have to say why.
I mean, think about this. How many steps are there?
5.
How many letters in 5?
What?
How many letters are there in 5? And this is which day of this thing? This is a set. And 4 times 2 is? There you go. There's a formula. What?
How many people think Rick could probably come up with another formula if you wanted him to?
Well, I mean, but the other formula, the answer should come out to be what? Yeah, well, that's if you spell 5, what's the last letter?
E.
And what's the first number that starts with E? There you go.
2 formulas you got now. Aren't you happy?
Now, so I'm curious, because this comes up a lot when we do professional development. It's like, okay, if you give me a formula, that means it must be right. But what I want to do in this, to me, gets back to this idea of contextualizing. When you go back to that formula, the first one I used, did the number of days that we've done this institute have anything to do with the problem? Okay, then, I mean, it's probably not. So what I'm looking at is not so much a formula, but kind of a mathematical reason, or just, not, I don't know if it's mathematical even or not, but just some sort of logical reason how you know that's all 8. And I heard somebody talking about this, and I saw a bunch of this when people actually wrote them out. I would like you to think about those 8 and see if you could put them into 3 groups. If you could take those 8 and put them into 3 separate groups, and then if we could say that those are the only 3 groups, and we could make a reason why we know all, we had all of them in each group. How many people have an idea what one of the groups is? One of the groups. Who could tell me what one group is? What's one group? One, all ones? So, now just to show that I am capable of being nice. How many people that one has all ones? How many people are pretty darn sure we have all the ones that go in that group? How many people that qualifies as a duh question? All right. Talk in your groups and see if you can think, what are the other 2 groups? And in each of those groups, how do you know you have all of those that go in that group? Okay? What are the other 2 groups? And how do you know you have all the ones in each of those groups? How many people know what one of the other groups is? What's one of the other groups? I got a tricky question for you. You haven't even thought about this yet. Show me on your fingers how many members there are of the smallest of the remaining 2 groups. Yeah, I know. Huh? So there's 2 groups left, right? How many are in the one that have the fewest? How many people agree there's 3 of them? Can somebody tell me what's one of the 3? Take a hand for what's one of the 3. One of the 3. Katie?
1, 2, 2.
How many people agree this is one of those 3? So, how many are in that group, everybody? How do you know there's just exactly 3 and no more? Can somebody give me a reason why that's true? Is that a hand coming up? All right. Tony?
3 place values.
What does he mean when he says 3 place values? Does anybody have an idea for that? What does he mean? We're not sure. Anybody want to take another start at it? Deanna?
There's only 3 positions for 1.
How many people agree with that? How many feel like that's what Tony's talking about too? So when they say that, they're fixing what first? What are they moving around here? So what are they fixing? I mean, they're fixing the 2s and then moving around? If I think about that, if I put 2 2s up here, how many people can see exactly 4 places where I could put the 1? How many people can't see 4 places? How many people see more than 4? Fewer than 4? Can somebody tell me where one of them is? Just describe where one of them is. Take a hand. One of them. Francie. How many people, like one could go right here? Another place, just holler it out. Here? And? How many people think, once you look at that, that's a pretty solid explanation for why there's exactly 3 of those? How many people did the same thing, or not the same thing, I guess, But a similar explanation for that group. In that one, what did you fix first? How many ones, everybody? If I put 3 ones up here, what's left to make this thing go up 5 stairs? 2. Show me on your fingers how many places there are to put that 2. How many people are seeing 4 of them? How many people think, wait, I got to ask this. I never thought about this before. You're going to like this. This is pretty cool. 4. If I go like this, what do these spaces between my fingers represent? How don't you think about that? How many spaces to put the 2? There's 4 of them, right? What do these spaces in between represent? How many people, if I put a 1 here, and a 1 here and a 1 here, you got all 4 places to put, that's really stupid. How many people see those 4 places? So, you know, I can't believe how many times I've done this problem and everybody makes the same mistake. How many people agree that that's a solid reason for there's exactly 4 ways to use 3 ones?
Ooh, see, they're worried they made a
Wait a
mistake.
minute now.
They won't raise their hands.
How many ones do we have here? So I could put a 2 here, 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 here. How many people think those are all the ways with 3 ones and a 2? And how many people think these are all the ways with 2 2s and a 1? And this is all ways with 3 ones. People, 5 ones. 5 ones. 5 ones. I lied. Sorry. Every time I do this, people leave off the ways to do it with 4 ones. Huh?
Because you would be 1 step short.
Did we talk about this last time? Oh, let's talk about this.
Neglected
you know about
it.
this. So one of the things I like to use in my classes, have you seen this symbol before? Some people have. This is a symbol for silent.
They said we did it last Tuesday.
I have a difference of opinion, huh? You mean you're out? Yeah, yeah. So anytime you hear something, you have a difference of opinion, you can go like this. So I'm going to say that again. Suppose I think I have a way of doing it with 4 ones. How many people have a difference of opinion? Why can't you do it with 4 ones? Take a hand for that. Why not? Why not with 4 ones? Tara?
You'll be 1 step away from being in the top.
How many people agree with that? And if I say exactly 4 ones, my only option left is how many steps?
1.
And but I can't do 5 ones, so I'd have to do a 2, but that would be
6. Yeah.
which is where the saying comes, too much. Just in case you didn't know. All right, so how many people think we have a pretty solid reason that there's exactly 8 of these? Broken this down a little bit? Okay.
We can quit looking?
We can quit looking, I think. All right, well.
What's the formula?
I'm not, you know what? I'll say this for people who want. There's a way to get a formula for each of those 3 groups. There is a clever way of it that somebody wants later. I'll show you. There's a clever way of looking at this problem to come up with a one-shot formula. Now, I think you still have to put it into categories, but that's okay. But I'm not going to do it right now. Here's what I really want to know. Yes?
Before you go on, how many people remember the other formulas Rick told us about how to get 8? Yeah, those. How many people are more convinced by our solid argument up here than they are about Rick's formulas? Okay.
I'm insulted.
I'm sorry.
Again. Well, okay, let me just, one more thing before I send you. How many people think it was apparent last time we were here that we care a lot about reasoning? Okay? All right, so I mean, and this reasoning, the idea we look at this, take you kind of out of the context of what you teach into something that really doesn't have any prerequisites, and we look at the reasoning, and then we can apply that same standard of reasoning to what we teach. Okay, so that's kind of where we're trying to head here. All right, so more interesting stuff, because this is just a cool problem. You're going to see it just gets cooler and cooler as we go. What if there were a different number of stairs than 5? So what I would like you to do is...
We have time.
We have time.
Yes.
I want to know if there were 8 stairs, how many ways would there be? But before we start, guesses. Guesses. Now this is a cautious group, I know.
Maybe they'll write it on their whiteboard because then it could be erased.
Yeah, okay. But if there were 5 steps, how many ways to go up?
8.
So any guesses for 8 stairs? 24, I like that. Anybody else? I heard a number somewhere. What? 40. Anybody else?
Still just 1 and 2 combination?
Still 1s and 2s, yeah. It could be all 1s, it could be all 2s, but no 3s. That means you're not going to guess, though. 22. How many people think somewhere in the 20s? That seems to be kind of popular. Somewhere in the 20s? Fewer than 100 again? All right. I'll even tell you this. I didn't ask you to list them.
You didn't ask them to list them. You just want to know how many.
I just want to know how many about. By the way, how many people, it was kind of cruel to ask that? Kind of, not cool, I know, but cruel. Cruel. But how many people it would have been even more cruel to ask you for 10 steps? No, I'm not getting, yeah, thank you. I've got a hand. How about how many people would have been even more cruel to ask for 40 steps? I'll get it, 50 steps. Now, I'm going to ask, if you don't raise your hand and say it would be cruel, I'm going to ask you to do it. How many people it would be cruel to ask for, all right. So here's what I want you to think about.
They got to pause to think, though, huh?
Yeah, you got to pause. So if you're
Give you some more time. Pause.
I want you to think about any number of steps you want. And there's some easy questions there and some difficult questions. But I want you to collect data for different numbers of steps. Right? See what happens for different number of steps and see if you notice something interesting. Okay?
Any number I want?
Any number of steps you want. But write out actually how many there are. And then keep track of your data and see if you notice something interesting.
So I don't have to do 8.
No. And if you need a hint, I'll give you a hint. I'll give you a hint. I'll help you because I'm a nice guy. If there was 1 step, there'd only be 1 way to do it. So there you go. I'm helpful.
That's a gift. Thank you.
Helpful.
Little time out. Can you put your hand on your head? Your writing hand on your head, please. Your writing hand on your head. You're writing a little time out. This is about like a 42-second interruption, and then I'll give you more time. Okay, writing hand on your head. I'm looking around to see if I got everybody's writing hand on their head. If you see your neighbor doesn't have their writing hand on their head, tap them, please. Writing hand on your head. Cool. Thank you. All right. So now.
Tap them with your non-writing hand?
Yeah, you do. Tap them with your non-writing hand because you don't want to hit them with your head, right? So not like that. All right. So now I would like you to show me in your fingers the number of stairs that you and your group are choosing to look at, and I want everybody to look around. So show me in your fingers. How many stairs are you doing? Are you doing 8? Are you doing 2? Are you doing? Rick did 1. So show on your fingers. Hold them up, and look around. So I am seeing 7s, 6s, 3s, lots, 4s. So what I haven't seen, I would love it if somebody would check out 2 steps, because I haven't seen. Anybody done 2 steps? Oh, some people are doing 2s. Good. And I also didn't see 5s. Oh, how many people think we already did 5? Okay, cool. So I just wanted you to just know that that's going on in the room. So please check them all out, because you have the power to choose, all right? Okay, that was 42 seconds. Go ahead and go back in your groups and keep gathering.
Okay, 2 steps is 2 ways. 1 step is?
25 so far.
No, but I mean, how many different numbers of steps do you know the answer for?
Well, I think 4 steps is 4, and 6 steps is 9.
11. I got 6 steps.
Did you?
So keep track of the ones keep track of the number of steps you've done for sure and compare and make sure you're right, and then see if you can see a pattern. What do you guys have? What's the data collection over here? What do we have so far? How many number of steps have you done?
Joe, does this have anything to do with binary code, ones and twos? I mean, is it related?
You could probably make it. So
So we were trying to follow the pattern how we did with the 5 with,
yeah.
so you're trying, but what comes up is when you have, we're discovering different.
Oh, with a lot of steps, yeah, gets harder.
Yeah.
So, do you know how many ways there are with 5 steps? Do you know how many ways there are with 5 steps?
8.
8. Do you know anything else for sure? Any other different numbers or steps?
2 steps and 5.
Is 2?
Going down in a path.
So look at the different number of steps and see if you notice something. Make sure when you get your data, though, that you compare, make sure your answers are right. I'm going to interrupt you for a second. How many people, actually more than a second, how many people are starting to find something interesting going on here? I want to collect some of the data here that we have. If I look at this, if I put a 5 here and an 8 here, how many people have a sense of what these 2 columns mean in this T-chart? Can somebody raise a hand and tell me what this one is? What's this one? What's this one? Stacy.
Steps.
How many people agree that's 5 steps? And the 8 represents, so take a hand for that. What's the 8 represent? I knew this a minute ago. Francie.
Combinations.
How many combinations? Which doesn't? No, I'm not making another stupid joke yet.
Could you hear?
How many people agree with that? Can somebody tell me well, how many people found it useful to look at smaller numbers of steps? 1 step, how many ways? Are you sure? Yes. So we're sure of these 2? Yes. All right. 2 steps? 3 steps? How many people looked at that and said, oh man, I see a pattern?
Take it to 5.
And so 4 steps would be? 5. There goes that pattern, huh? By the way, I always think this is funny because how many people have seen people say, well, if there's 3, if the pattern has 3 things, then it works. I hear that argument all the time. But 4 steps, how many ways? 5. Now, by the way, how many people on the, like we're sure of this, you listed them out and you're positive? How many people, now I want to hear numbers yet. How many people looked at that and made a conjecture for how many ways there would be if there were 6 steps? See, I really like this way of thinking that I saw a bunch in the room. People got here, they got to 6, and then they said, well, let's make a guess, and then let's check it out. So here's what I want to know. I saw a couple very logical guesses. And I'm not interested in the correct answer unless it was a guess. Can somebody tell me a guess that they had?
You're not interested in the correct answer?
If you had a guess and then found out it was wrong, I still want to hear your guess that was based on what you saw up there. A guess from Janet. Is that Janet? That's Erica.
Okay, what was the question? Okay, my hand was very enthusiastic, sorry. What was it?
Just what your guess was for what number was going to come next.
13.
How many people guessed 13? And I saw at least one other really logical guess. Another really logical guess. Now, you know what? If I call on Tara and you go over there, she's going to say, I'm a teacher, so I don't need the mic. Tara.
12.
I think she's right.
Now, here's what I want you to do. How many people made the guess initially 13? How many people made the guess 12 initially? If you made the guess 12 initially, I want you to look at that and see how people could have come up with 13. And if you guessed 13, I want you to look at that and see how people could have come up with 12. If you didn't guess either one, take your pick. That's a little bit of a confusion issue, but How many people who did not guess 12, if you did not guess 12, how many people can see how somebody could find a pattern up there to get 12? Let me ask that again. If you didn't guess 12, can you see how someone could have gotten 12? This is something we're going to talk about this when we do teacher or debriefing. Diana? Is it Diana? Yes.
How could they get 12?
Yeah.
They would just add each time. So 3 plus 2 more gives you 5. 5 plus 3 gives you 8. And then 8 plus 4 gives you 12.
Everybody, what do you add here to get 3?
1.
And then add?
2.
And then add?
3.
So it would be logical to add?
4.
And get?
12.
How many people think that's a very pretty pattern? All right. And can somebody who originally guessed 12 tell me how those people could have gotten 13? Take a hand for that. Somebody who guessed 12, can you see how somebody could have gotten the 13? Deb, would you call on that person, please?
Karen.
Karen.
We were adding, we were going like 1 plus 2 in the combinations column equals 3. 2 plus 3 would equal the 5
How many
combinations.
people agree with that?
5
Everybody,
plus
what
8
number
would
is
equal
she going to add to get 13? 13. Is? 13. How many people? We have 2 nice patterns. 2 nice patterns. That's a problem. All right. Well, let's see. Let's do this. And did someone in the room actually do all the ones for 6 steps? We're hoping they either got 12 or 13, right?
Yeah.
Would someone like to share how many they got? Saran? Saran. How many people got 13? 12 was a beautiful pattern. But 13. All right. Now, wait, let me see. How many people also got 13? And were you careful about organizing like we did over there so you knew you had them all? All right. Well, let's do this.
Get some lists up?
Huh?
Should we get some lists up?
Yeah, I want to get a list. Let's get all 13 up here. Somebody want to start me? Deb, you want to call on people and I'll write?
You're getting the list of 13 ways for 6 steps, right?
6 steps.
So who's got a way? Karen, give us one of your combinations.
All ones.
How many people think that group's done? All right, somebody get us started on a next group.
All 2s.
How many people think we can do that this time? Cool. Somebody got another group. How many people think that finishes the all 2s groups? We're done with those 2 groups. Cool. Somebody got another group, another group, another group, another group. I may hand it off to Carrie, but I'm stay on this side. Sorry. Normally I would be calling on people opposite me, but I can't do. Oh, you can, Carrie.
Someone had a hand up. No, it went down. Oh, here we go. Courtney.
1, 1, 1, 1, 2.
How many people have a sneaking suspicion if Courtney was going to keep on going? If Courtney was going to keep on going, she would do another one in that same category.
Everybody, what is it?
1, 1, 2, 2, 1.
Another one.
1, 1, 2, 1, 1.
Another one.
1, 2, 1, 1.
Another one.
2, 1, 1.
Another one. That's it for those? Okay, somebody, that's not 13. Oh, that's 7 though, and 7 plus 6 is 13.
They're not going to fall for that anymore, Rick.
Another one, Stacy? Oh, I'm sorry. Somebody. No, not just any. I don't just one.
Janet.
I have 2, 2, 1, 1, 2, 1, 2, 1, 2, 1, 1, 2, 1, 1, 2, 2, 1, 2, 1, 2, 1, 2, 2, 1. And that's 6 of them.
How many people are happy that she did that one?
How many people think there's 13 of them up there? How many people are pretty sure there's all of them? All right. So, Hate to do this to you. I really don't hate to do this to you, but I thought I'd say it. I really want to do.
Is your nose growing, Pinocchio?
How many people know the three-letter word that I'm going to ask next?
Why?
Because I want to know. Oh, no, you meant. So, how many people think we have a pretty pattern? I want to know now. We're escalating questions here. This is definitely the hardest. Why is it that the number of ways to go up 4-step, and I know I don't want somebody to say, well, 5 because 5 plus 8 is 13. That's not what I'm looking for. I want to know why is it that the number of ways to go up 4 steps and the number of ways to go up 5 steps, why do you add those 2 ways together to get the number of ways to get 6 steps? Because, yeah, I want that word in there. So now, the deal is, how many people think we have a really nice, pretty arithmetic pattern? So one of the things I like to ask, could someone, a fairly sharp person, walk in the room right now and look up here and say the next number is, what is it, everybody?
31.
Could somebody look up here and without even knowing what the question is? So 21, if they don't even have to know what the question is and they can get the right answer, that's not, they don't have a reason. I want you to put this in the context of steps. Why is it that you add these 2 together to get that, not arithmetic? And that's a tough question.
So in the context of steps, you want us to do this?
I know somebody's going to get this, but I'll just tell you right now, this is not the reason.
You going to tell us what it's not?
Never mind, I won't. All right, so see if you can come up with a reason for why that's true. I guess I could ask you this. How many people think this does qualify as a tough question? This qualifies as tough. All right, I'm going to give you a little nudge in a direction. A nudge in a direction.
A nudge.
A nudge.
Nudge.
So, here's the deal. Here's the deal. How many ways are there to go up 6 steps? So, and 13 came from? 8 plus 5. I want you to look at those 13 ways, and I have to be careful about how I ask this question, but let's see. I want you to take those 13 ways and see if you can break them into 2 separate groups. Okay? Guess, wait, now not yet, because I got to ask, there's more to this question. How many groups?
2.
Anybody got to guess how many are going to be in the smaller group? Without even looking up there. I'll go back and ask a different, you ready? Another question. Everybody, where'd that 13 come from? Everybody?
8 plus 5.
And I'm suggesting to break them into how many groups?
2.
Anybody got to guess how many are going to be in the smaller group?
5.
Good guess. Which means how many in the bigger group?
8.
Okay? Now, so this is something that, and I'm not suggesting you do this problem with little kids, but I think little kids can come up with this. Think about this. What are there 5 of up there? And what are there 8 of up there? Now, where I have to be careful, when you do that, I can only think of this in this terms. You have to have, both statements have to be positive. You can't say there are 5 of these and 8 that aren't. Okay? So I want a positive statement about what there are 5 of and a positive statement about there are 8 of. So talk in your groups about that, see if you can come up with that. You got an idea back here?
Oh, yeah, you can. Oh, yeah, you can. I've seen little guys thinking like this.
Wait, do we have an idea?
No.
You're not going to tell me.
When my kids were little.
Wait. You're not going to tell me? You have an idea yet?
Oh, well, I haven't figured it out. I don't know. We're thinking, what did you say? The number of digits. The number of digits. 3s and 4s go in one group and the rest goes in the other.
Oh, but see, now I can't say the rest. I'll tell you what. I'm going to tell you. Those first 3 that you told me about, these guys over here?
Yeah.
These 3 go in the same group. And that one goes in a different group.
12.
Right.
That's 12. You said a group of 8 and 5.
Well, of these 4, there's 13 up there. This one, and this one would go in the same group.
Because they start with ones.
Oh, these particular numbers.
Can't say it that fast. You're a kindergarten teacher.
These particular numbers. Is that what you're saying?
Now look up there. How many up there are there that start with 1?
3, 4, 5, 6, 7, 8. Oh, and I'm missing one here. What am I missing?
8.
And how many are there that start with 2?
2 with, I'm
1,
missing
2, 3, 4, 5.
Huh. Huh. We've been holding out on these guys all morning for it. So now let me ask this question.
When a long time ago, Mr. Jansen used to
Hold on a second. That 8 up there, when we got 8 for 5, that came from what arithmetic problem? If you look at the column where we did the pattern, that 8 came from what arithmetic problem? 3 plus 5. See if you can use her same idea over here. Does it break into 3 and 5? Look at these guys over here and see if it does the same thing. So that's what they pay me to do. Someday I'm going to figure out answers, and then I'll be dangerous. So if I went up here and I just did this, if I circled that one, show me on your fingers, are there 8 of those or 5 of those? In this, the group that this belongs to, are there 5 in that group or are there 8 in that group?
5.
How many people agree there's 5 of these? So here, I'm going to point, and I want you to say yes when I point to one that's in the same group as this one and no if it's not. This is a challenge, huh?
No. No. No.
This is a negative group.
Yes. Yes. Yes.
You thought I was going to do this one, huh?
Yes.
This one?
No.
This one?
No.
This one?
No. Yes.
Yeah, you can say that's 5, so I quit.
No. No.
I'll take a quiet hand for what do those 5 have in common? What do those 5 have in common? Please, 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 Robin.
They all begin with 2.
How many people agree with that?
Oh my gosh.
You did say gosh, right?
I said gosh.
Oh, well, if you said that, then I'd say, please, my name's Rick. Just call me that. Let's see. That means all the others start with
1.
How many people think that's probably more than just coincidental? All right, I want to just go back and look at something real quick here, and then we'll talk about this some more.
Thank you for writing nice notes to your buddies. So we're going to go back through the morning's STAIR lesson with our teacher hats on. So I don't know if you guys can do that, because how many people recognize that we sort of left you with an open question? How many people are still working on 1s, 2s, and 3s? Okay, so you're not doing that. So could you find on your messy table, there should be a half sheet. And there's a half sheet and it says a 2 and a 3 on it. And there's a whole bunch of paragraph writing. I see that Courtney's friend has it holding up. Tom, no, that's not Tom. Robin's holding it up, right. So one of the reasons that we do the morning problem is not because we're saying you guys need to go do that 2-hour problem with your kids. That is totally not why we're doing it. What we're doing is we're trying to provide a forum for us to be able to feel what it feels like when we're really understanding stuff and how these standards for mathematical practice come to life, because we didn't necessarily learn this way when we were doing math. So it's good for us to have a handle on what it feels like viscerally. And now we're going to go back with our teacher. So you just had a learning experience with that. Now we're going to have you step outside of that and think about what we just did with your teacher hats on. So that's where we're at now. So I ran off these are the paragraphs that come straight from, we've given you various versions of the standards for mathematical practice. Those are 2 of them in paragraph form. And what I want you to think about is when you read this, where did you feel yourself and your group mates doing it? And what were the prompts that caused you to do those things? Because those are densely packed paragraphs, so just take a minute to read through, and then as it looks like the rest of your group mates are ready, you can start talking about a couple of places where you might have noticed you caught yourselves doing it, and I want you to think about what prompted you to do that.
About this some more. This 8 came from what arithmetic problem, everybody?
3 plus 5.
Then we should be able to break those 8 into a group of?
3 and 5.
Would anyone like to get me started on either of the groups? Tell me what's true about either of the groups. Either one. Either one. Tony.
You could circle all the ones that begin with 2. There's 3.
Well, let's see. What can I do here? How many people agree there are? Let's see. That starts with 2. That starts with 2. That starts with 2. How many of them are there?
3.
Which leaves how many of the others?
5.
How many people that coincidence even looking better now? All right. So can somebody tell me this? In the context of the problem, do there have to be 2 groups? One that starts with 1 and one starts with 2? In the context of the problem, why are there only 2 groups? Tom?
Because there's of all permutations of numbers, there's always a group where you skip the first step. And are left
So, how many people think one of my choices is to go and skip a step? Show me on your fingers how many other choices there are. How many people agree there's only one other choice, which is what? Right? Just take the. How many people think you got 2 choices of how you start? Nice, nice, nice. I like that. All right. Yes. Oh, okay. Well, here's what I want you to do. I want you to see. I want you to talk in your groups to your. So let's see, this next one here, if there were 7 steps, there'd be how many ways, everybody? And it came from? How could you take that list, which has how many in it?
8.
And this list, which has? How could you take and use those 2 lists to come up with this list? Talk about that in your groups for a second. How many people think you could have looked at the end as well? In other words, there's, I have to think. There's 5 that end in 2 and 8 that end in 1. Okay, either way, and I thought about saying that. For the purpose of in here, since it came up first, let's focus on the beginning, but it really doesn't matter. You could do it either way. So what could you do to that list and that list to come up with the 21? Talk about that, and then we'll go from there. How about this? We're trying to create the list to go up how many steps?
1 more. 7 more.
7 steps. And how many ways are there to do that?
21.
We think that's true from over there? All right. Let me make sure we're good on this. We're trying to go up how many steps?
7.
And there's how many ways?
22.
And my question is, I want to know if I have this list already and that list already, could I use that information to come up with these 21?
Yes.
How many people think you could do that? So go ahead.
How many people think it'd be nice if we could not have to start over and build it, and we could build it from previous 2 lists? How many people would that be nice?
So, what color do I have in my hand? Purple. This will work. Could somebody make a suggestion? If we wanted to create this list of 21, can somebody make a suggestion for what we would do to this list? What would we do to this list over here? Gail. Nope, not Gail. Lori.
Put a 1 in front of every single one of those.
How many people think, oh, by the way, are any of these the same as one of the other one in the list? No. If I do this, if I put a 1 in front of all these, we now go up how many steps?
7.
Because before we were going up,
6.
and we've added
1.
Yeah, that makes 7, huh? Are any of these the same? How do you know that? How many people think they weren't the same before? They're not the same now. All right. How many people think that's pretty clever?
Now those things are no longer six-steppers?
Yeah. Oh, by the way, how many of these are there? 13. That means there must...
Dang it. Where are we going to find
Went
those
like
others?
that before I even asked my question. There's how many left then? Where are those going to come from? How many people think over there? All right. How many people think we're going to have an idea what we're going to do to these? How many people think we have to add something? Show me on your fingers what we're going to add to each one. How many people are thinking 2? Does it matter where I add that 2? Where would you like to add it? I don't know what all this mess is up here. So if I do that, I've now made each one of those go up how many steps? And there are how many of these? 8. And how many of those? 13. And 8 and 13 is? 21. Yeah, I know that feels pretty good, huh? But guess what? I got a problem again. I have problems. There's one on that list that's also on that list.
How is it?
Some people aren't buying that, Rick.
Well, they all look like they don't have a difference of opinion.
I know, they do look like the... Oh, now they look like they have a difference of opinion.
How many people think there's not one on that list that's also on the other list? Now, you did that. You said that pretty quickly. Didn't you look at them carefully? You did. You just did it fast. Can someone tell me, well, I want you to discuss this in your group just for a couple seconds. How do you know without even looking that there's not one of those that's also on that list? Talk about that. How many people have a pretty solid reason without even putting a list and comparing why there is no element of that list that's on that list? How many people, can somebody tell me? Courtney, microphone.
Oh, what was the question, Courtney? What was it?
How do you know without looking?
Oh, because we added a 1 to the front on one side and we added 2s to the front on the other side. So they all start with 1 and they all start with 2?
Yeah.
You're allowed to clap. That's okay. So, hey, this goes back to our 2 possibilities for how you start, huh? So let's see. If I went way down here on this list to 99, like something weird happened. 100, never further. 100. If there were 100 steps, what information would you need to know in order to answer how many ways? Take a hand. Take a hand. What would you say? What would you say? Tom, right?
You have to know the number of permutations or combinations for 98 and 99.
How many people agree if you knew 98? Oh, look at all those. Let me do that again. That was good. I like that. How many people, if you knew 98 and 99, you could do it? I'll tell you then. 98 and 99. 98 is A and 99 is B. Everybody, what's this? How many people agree with that? There are going to be, this is a dirty trick. Show me on your fingers, what do all these, the B, what do they start with? I'm sorry, never mind, I lied. How many people think some of these came from this B right here? What do all these start with? What did you have to add to this list to make it the 100 steps? How many people you had to add to 1? So of these, there's B of them that start with 1, and how many that start with 2? Okay. How many people agree with that? Okay, now I want to just real quickly, because I want to twist this problem. We didn't think we'd go this far, but we're going to do it anyway. I want to put this back in the context of the problem. So you guys told me a while ago, and this is one I think little kids can understand as well, you know, even with big numbers. So you told me there's how many ways, how many decisions on the first move?
One. Two.
How many decisions? Oh, no, one decision. How many options?
Two.
One of the options is?
One.
If there's 100 steps, we'll pick a smaller number. If there's 7 steps, and I go up 1 step, I could write this out in English. If there's 7 steps and I go up 1 step, how many steps are left?
6.
And do we already know how many ways there are to finish that off?
Yes.
How many ways to finish that off then?
13.
That's one of my options. So I could say this. I wonder if I should write this.
Or them.
I'm going to have them say the next one, Coralie.
Okay.
All right, so you have to listen carefully, because if I wrote it, you'd never be able to read it anyway.
You want me to try and write it on the DocuCam?
No, that's okay.
All right.
So there's 7 steps. Ready for this? If I go up 1 step, there are...
6 steps.
And how many ways are there to go up 6 steps? I think we could do the other part, Coralie?
Yes.
If there are...
7 steps.
And you go up
2 steps.
There are 5 steps left and 8 combinations.
You guys rock.
Want to try that one more time? So let's do this. Talk with your neighbors. If there's 100 steps, I don't care which one possibility. If there's 100 steps, say one of the possibilities. How many people are able to come at least close to that? So I could say if there's 100 steps and you go up, there's how many left? And there's how many ways to do 99?
B.
All right. How about I got to mess you up here. So you remember I stopped this because some people in the room added the 1 and the 2 on the end. How many people think those, as long as they're consistent, how many people think we could have made the same argument by taking this 1 right here and put it on the end instead? Yeah. As long as we...
Do the same thing. The 2 at the end there.
What does that sound like when you put the logic in terms of the steps?
Consistency.
Anyone like to? Instead of how many options are there to start, what would we talk about? How many people think we'd be talking about the end? Yeah. At the very end, you could have gotten to the top by taking
1 step.
Or 2 steps. How many people agree? So, like if this is the very end, there's a bunch of junk in front of it. How many people think you either to get here's our goal right here. Here's our goal. How many people you could have been there right before?
Well, you're going to fall down the stairs and do that.
All right, well, then how about this? Suppose you were at the top of the stairs and there were 7 stairs. How many ways to get down? How many people think there's still 21? All right, you guys are terrible.
How many people think you could keep messing with that context and kids could still keep reasoning about that right there?
Technologically challenged. How many people think see, I'll just go like this. How about that? Does that work?
Yes.
Hey, that worked. I didn't think it would. How many people think if this is my goal, right before I got there, I could have been here? If I was there, if this is 7 steps, if I was there, how many steps have I already gone up?
6.
And how many ways are there to do that?
13.
Where else could I have been? How many think I could have been there? Are those the only 2 options? If I got there from here, it means my last step was?
2.
And how many were there before that?
8. 5.
Yeah, and so how many people we can make the same in-context logic that way? All right.
How many people think we explained our formula for adding the 2 previous in terms of the steps? Yeah.
What do you want to do?
You tempted?
I'm tempted.
We can do it. These guys are good.
All right, you guys are good. Here's what I want you to do. And I am saying it is very unlikely we will get to the same level of sophistication at this, but we'll talk about this in the debrief why I like to do this anyway. Anybody know where I'm going next? What if I could do either 1, 2, or 3 steps? Here's what I'd like you to think about for a second. Ready? Now this is a challenge. I treat you like big kids. All right. The first thing I want you to do is just talk in your groups and share some ideas for 30 seconds or so. What do you think's going to happen? And then try it for 1, 2, 3, 4, 5 steps and see if what you think happens. Okay, we'll see if we get that. We're going to only take 10 minutes at the most. How many people have already done 1 step? How many for 1 step? Okay, good.
Or just note it too. All you have to do is figure out how many you're adding on to the original one by adding 3s into it.
Okay.
So I'm not seeing, at first I thought it was a times 2 minus 1 times 2 minus 1, but it no
And
longer
that
was
didn't work?
there.
So you got another way to get that 13 and that 7? Follow these out. 1 step. How many ways? 2 steps. How many ways? 2. I see a pattern. No. I get a no back here. 3 steps. Oh, now I know. I see a pattern. One might guess what for 4 steps? Does it look like it's doubling? Looks like it's doubling, huh? But 4 steps is how many ways? What a pity. And did anybody do 5 steps?
13.
13. You know what? I would really, really, really like to talk more about this, what the pattern is and why, but we just don't have time. So I believe we're taking a 20-minute break.
How many people think that's really sneaky to leave you hanging right here? How many people think that's good that you're still wondering and looking about math? Yeah, right? Okay, something we're trying to do with our kids. So, before you go actually to your break, I have this note I'm trying to remember to do that Carrie wrote me. How many people notice that there's some little slivers of paper that are colored on your tables? Like that, green one? Little slivers? Do you have little slivers hiding? So maybe somebody in your group was kind of helpful to you today, and we'd like you to write them a nice note. Dear Rick, thanks for asking that question about the 3 steps, because I really wanted to do it. But Rick wasn't at your groups, so maybe Dear Saran, thanks for drawing that picture, because that really helped me out. And then you can hand the person a nice note when they get back from break. You can just leave it in the little spot, all right? So write somebody a nice note that worked with you at your table. Positively reinforce that behavior they were doing that was helping you out. Thank you for writing nice notes to your buddies. So we're going to go back through the morning's STAIR lesson with our teacher hats on. So I don't know if you guys can do that, because how many people recognize that we sort of left you with an open question? How many people are still working on 1s, 2s, and 3s? Okay, so you're not doing that. So could you find on your messy table, there should be a half sheet. And there's a half sheet and it says a 2 and a 3 on it. And there's a whole bunch of paragraph writing. I see that Courtney's friend has it holding up. Tom, no, that's not Tom. Robin's holding it up, right. So one of the reasons that we do the morning problem is not because we're saying you guys need to go do that 2-hour problem with your kids. That is totally not why we're doing it. What we're doing is we're trying to provide a forum for us to be able to feel what it feels like when we're really understanding stuff and how these standards for mathematical practice come to life, because we didn't necessarily learn this way when we were doing math. So it's good for us to have a handle on what it feels like. viscerally. And now we're going to go back with our teacher. So you just had a learning experience with that. Now we're going to have you step outside of that and think about what we just did with your teacher hats on. So that's where we're at now. So I ran off these are the paragraphs that come straight from, we've given you various versions of the Standards for Mathematical Practice. Those are 2 of them in paragraph form. And what I want you to think about is, when you read this, where did you feel yourself and your group mates doing it? And what were the prompts that caused you to do those things? Because those are densely packed paragraphs. So just take a minute to read through. And then, as it looks like the rest of your group mates are ready, you can start talking about a couple of places where you might have noticed you caught yourselves doing it. And I want you to think about what prompted you to do that. So I want to repitch my question. So I was not asking you just to read about these and talk about how you do them in your classrooms or what they mean. I'm trying to get you to really focus on this morning. What was it when you, how many people noticed some words in there? Oh, it's hard to see up there, but you have your own version, right? How many people noticed some italicized words in there that you think we actually worked on today pretty purposefully? I heard someone say, a few people in the neighborhood, decontextualized. So that might be a place of, how many people noticed we were having you decontextualize the stair problem and just put it into mathematical terms? If I was looking on the whiteboards up here, how many people see a place that's probably more decontextualized than others? We've got that thing, we've got that thing, and we've got that thing. What seems to be the, where's this place where we were really decontextualizing? Anybody got some thoughts about that? Decontextualizing with just the math. I got a thought right here from Donna. Is that right? Dawn.
Isn't it where you've got the breakdown of the ones and the twos? Isn't that decontextualized?
How many people think we kind of left the thinking about stairs and we started writing these things to signify what was happening with stairs? Yeah? Okay. How many people think we also left what was happening with stairs when we figured out the 13 and the 12? For a while we had the 12. How many people think that was also, we were just doing some math, right?
You guys remember that question that you all thought somebody could walk in the room and not even know what the problem was and look and see the pattern? That's about as decontextualized as you can get. Don't even know what the question is and you know the answer.
So how many people think we were also yanking you back to the contextualized side when we were asking you? So I want you to talk about that in your groups. See if you can remember some prompts that Rick or I or Carrie, even when we were at small tables working with you, or it was a whole group prompt. Where were we actually yanking you back to the contextualized side? What were some prompts we gave you? So there were some times when we were totally decontextualized. Like I remember right in the very end, Rick had asked you guys, it was before we had this purple stuff on here. Before we had the purple stuff on there, show me on your fingers what's purple. Yeah, before we put those ones on the front. How many people remember that, right? Okay. And what I just said is decontextualized, because I just said how many people remember put the ones on the front. That's just all the math way, right? And then Rick was kind of yanking your chains and getting you to talk about, in terms of stairs, when you did the ones on the front, what did that mean in terms of, we were like telling the story about stairs. I don't think those were his words.
How many were left?
How many people remember when you get to the staircase and you're getting ready to, I heard some people say the question, but you guys couldn't hear it. Are you willing to say that again in my mic? Cool.
What choice would you make when you are looking at the stairs?
How many people agree that's a contextual way to say what we were doing for ones and twos? Yeah, so Rick's going to help me out next time, but although he's giggling, he thought that was pretty funny, so he may not help me out. I don't blame you. You owe me, buddy. I've been making fun of you, so you owe me. So that would be the contextual explanation for this. So that's what we're talking about. Kids need to be good at, and we need to feel what it feels like to go decontextualize when we're doing math, to start looking for the patterns and recording what we're thinking, and then go recontextualize or contextualize to actually see how is it sitting in that situation and can we make sense of it. So that's what we were, anybody else come up with other places where that happened in the lesson today, where we were doing that? At your tables. This is a hard concept. So, and plus I didn't tell you we were going to come to this moment where I was going to ask you what the questions were, right? Wouldn't that be, next time you know, yeah? You can be noting those things. Let's see if I could remember another spot. You got another spot. And here comes Rick with the microphone. I won't make you have to lean over.
When we were talking about the outcome of A versus B. So what does A represent? What does B represent? They're not just letters. They represent something.
How many people agree with that? That would be another place when you ask that question of contextualization. And there's another one back over here, Rick. I forgot her name. Is it Heather? Erin, that's close to Heather. Whoops. Sorry, Erin. Karen. Dude.
We were thinking when he drew the picture of the stair and he said at the very end I could choose between a 1 or a 2, that having the drawing of the stairs made it contextualized.
This one, like that? How many people agree with that? Oh, it's upside down? That would be fair game. Right, so right there, how many people agreed that was, what'd you say that was contextualized? How many people agree with that? Okay. And sometimes another thing to even think about, I don't know that it says this here, but I'm starting to think more about it in my own mind, is I need to really think about when is it good time. Like Rick decided he was going to draw that picture to pitch the question he was asking you, and he decided that would be a good time for us as learners in the room, for him to actually go with this context and actually draw the picture. Sometimes I need to think about that. When is it a good time for me to go to context, because then the learners in the room are going to be able to go to the next level, as opposed to me just only using context for that thing that's just the hook. A lot of times in education courses, right, they say, where's math going to apply? That's what you're supposed to hook the kids with at the very beginning of the lesson. And that's the only thing I usually hear about context. But this time, I'm starting to think more of, I can use it as a tool when I need to. And in this case, Rick decided this would be a good way to pitch this question. So he went to context, as you noticed. How many people agree that that was a nice place to have a way to grab onto the visual in your heads when you were trying to then make the next part of the argument about options? So thinking about how we can use context in itself as a tool to help kids make the next leap in reasoning is a good thing. All right. Any other spots people were noticing and talking about? We got one way over here. I can probably lean. She'd probably be all right. I'll just go like this.
When we went from the T-chart and the A's and B's back to now take it to 3 steps. You can do 1, 2, or 3 steps. That took it back to the stairs.
How many people agree with that? How many people have already noticed a kind of a fun thingy on the decontextualized side with that? A few people. Interesting. Okay. All right. Nice.
So I have a question that's a slightly different direction, but that picture that's up there with the goal on the top, had we already done something that helped you before that? Is that a lame question? Yeah, okay, that looks like a lame question.
Well, you know, no hands is one way of getting feedback.
Yeah, well, so there's a reason why I asked that question with our goal was at the top and how many places, how many options did you have to get there? Was that like a repeat of something else? What did you guys already told me before that?
The same as the 2 ways to start at the bottom would be the same as the 2 ways to end up.
How many people agree with that? So, if it's the same, why did I ask it? Do you want them to talk in their groups about that?
That's a wonderful idea.
Talk in your groups. If it's the same, why did I ask that? I want to hear what people think about that, and I'm going to change my question a tiny bit. So what might that do, not necessarily for you, but what might that have done for some people in the room as a learner to do that second way? Any thoughts about that?
After we already did the first way.
After we'd talked about starting at the bottom and the 2 options, and now I go to the top. What might the purpose of that be for a learner? Deanna?
I'm not sure if this is your angle, but to make it okay to think of it differently.
How many people agree that's a nice thing? Because we did have people thinking about the end. Any other thoughts? Tom?
Well, the connection I made was if by saying that you could make a choice to start with 1 or 2 steps at the beginning of the stairs or end with 1 or 2 steps at the top of the stairs, it's the same exact decision as placing a 1 at the beginning of the sequences or a 1 at the end of the sequences on this side, or placing a 2 at the beginning or end of the sequences on this side. As long as you stayed consistent between the 2, it would work either way.
I see some head nod. That's true. Nice. One other thing I want to ask is, so suppose somebody, you know, because there's kind of all, well, how many people just, I have classes every now and then where people don't get it at the same rate. You know, most of my classes, all the kids get it all at the same time, and then, you know, and so that's easier. But, huh? What are you guys laughing at? Huh? I just said they get it all at the same time. It's 6 hours after I'd planned on it, but no. But I mean, so think about that in that context. If you have some people either that didn't or had a shaky understanding of starting at the bottom, how many people think there's a good chance that they're going to do better by hearing it again, only starting at the top? Let me see these hands. How many people think that's really right? So I mean, it's not, for me, one of the things I like to try and do is avoid going like this. The second explanation, it does not help to go slower and louder. All right? All right. So if I can take, for me, there's two things that happen here. One is the people who already got it, when I ask them this, do they have to think about it again? All right? I mean, because one of the things I find the biggest challenge in my classes is when some people get it and some people don't. What do I do to keep the people who get it challenged but not just forget the others? Or, you know, so I keep people challenged, but I think I saw a bunch of hands that the people who are a little bit shaky or didn't get the one on the top, at least some of them are going to improve their understanding or get it when we do the same reasoning at the top. So it gives people a second chance. And I think we'll probably talk about other places where we did that today too.
Am I off? No. That's exactly what I was going to.
You're on.
I am on.
Literally.
Good. I can think of another spot where that sort of thing happened. You guys remember when we were doing choral sentences together right at the end? I think he said something about, so if we were at 7 steps, and then you guys said there'd be 21 rays. And then he said, and then you started going and you said something about, and we'd have 2 options, and we could either go up 1 step, and then there'd be, and what'd you guys say? 6 steps left, yeah? And there'd be how many ways to do those? Right? How many people remember this? So, if there were folks that were having trouble right there, did we just do that again and repeat it? Is that what we did? Is that what we did? We just repeated the same thing? We went back through the same argument for 7 steps, 6 steps, 5 steps? Or did we do something different? How many people are not quite remembering because you were busy doing it? Yeah, I get that. I get that. I have notes about this. So how many people remember going down here? How many people think that was a very similar argument? And then we even changed mode of response. It wasn't necessarily choral. What ended up happening? Who got to talk about that one? In your groups, yeah. So how many people recall that's another place where instead of just going through the same thing twice, we then said, okay, try it again. Do it for the 100 and do it with your group mates. How many people can change in the mode of response and do it in another spot gives folks another access point. Yeah? So that's something to think about as you're going through. Is there another place I can do it instead of just repeating the same one? I can challenge the people that had it while I'm still giving another shot for the folks that don't if I just go to another spot. Another thing. That's on the content side. That's later when we start talking about planning stuff, like how you could do some of this sort of stuff only on the things you have to teach. You could be thinking about providing multiple access points for those same arguments. Okay, cool. That was one thing. I'm inclined to, oh, there was another thing that, it may come up here. So one of the things that we were really trying to work on is thinking about how to make it the most safe that we can in our choices of modes of response and our choices of tasks to get more and more people to feel like they have access to that math at that point and to engage. How many people can think of sometimes when you were learners in a different math class or that you've just seen maybe on TV of some things that get done in classrooms that don't make it so that people really want to engage in the mathematics because there's some practices that are happening in that classroom that make it a little bit unsafe for folks? How many people can imagine some of those things? How many people notice that we didn't do some of those things in here? So that's one thing you can talk about is what were we not doing? Another thing you could talk about is what were we doing? Because there may be some things that we don't, so what were we doing to try and make it safe? Like that last example I just gave. When we decided what to do with the 100, we could have said this. Who'd like to raise a quiet hand and tell me how that argument goes if we were at 100 steps? How many people agree? We could have said, who'd like to raise a quiet hand? But we didn't. I think Rick said, talk at your tables. How many people agree that was probably more likely to get more people engaged to talk at tables with a smaller group of folks than it would be to have one person want to raise a, how many people agree that would be getting more people engaged? So that's the sort of thing I want you to think about. What kinds of practices, instructional strategies are you doing to maybe make it more safe, more likely that people are going to get engaged? You can talk about stuff we didn't do or stuff we did do. And I'm thinking like maybe 3 minutes and then we'll share out. Is that cool with you guys? All right. Stuff we didn't do or stuff we did do? Thank you, Francie. Thank you, Robin.
What is silent? Silent what? Silent?
Ask me that in just a minute when I get everybody's attention. Raise your hand. Now, see, I should know your name. Begin with a T? Yes. Tara. No, but I remember it from last week when I called someone else Regina who wasn't Regina. Tara. And here comes Carrie for the mic so everyone can hear your question.
We were trying to come up with a list of different modes of response because it's been a huge thing that you've been pointing out for a year and last week and this week. And what was the silent?
Wait. How many people think I'm a little bit happy that she said that phrase? Yeah. How many people think Carrie and Rick are also happy? Yeah.
You can pay me later.
Okay.
What was the silent?
This symbol, so I've called it different things. It could be difference of opinion, silent intellectual protest. You know, it kind of depends on how your kids will feel it's cool, right? So obviously you liked the silent intellectual protest name. I just try and see if I can make sure that whatever we call it is building some respect in the classroom, right? So I don't want anybody like, no, that sucks, right?
I used to call this a disagreement symbol, and a friend of mine pointed out the disagreement symbol feels negative, but if it's a sign of intellectual protest or I have a difference of opinion, it's just not as negative. That's why I don't think it was in this group, but somebody, and I've seen this in class, I've seen this. Okay? I mean, is it really any different? I don't think so, but it sure feels different. You know, this is negative. This means didn't this mean you're voting for the Lions? I think historically. Yeah, I mean, I think.
He knows more history than I do. Gladiators, I hear. So how many other people talked about modes of response as something that came up that might make people more willing or less willing to share their thinking? How many people were also talking about other modes of response or, okay, any other? So that was, yeah. This one, how many people agree kids are going to feel pretty free to share this one? Yeah? That one's low level risk. If I have a difference of opinion, is it, yeah? As a matter of fact, if I'm the kid that does this, don't I really love to do this at the teacher, right? Yeah. So it's a whole other thing about involvement. Oh, that's one of those letters over there.
What's another real low-level risk mode of response for the kids? Yeah, I agree.
What was it? I missed it.
Somebody went like this.
Oh.
What mode of response is that, everybody? Show me on your fingers. Want to take notes at SMOYF? S-M-O-Y-F, show me on your fingers.
That's what I put up in the back of my classroom when I wanted to remember to use it more.
Think if you ask a question, show me on your fingers, what does it allow that kid who's unsure to do? Right? I mean, that, you know, easier show me on your fingers to check out what the smart people in the room have than to raise your hand to volunteer to explain something?
You're the learner, sure.
Going to be more inclined to do that, right? Okay. There's another thing sometimes people ask me about when we do this. Is do you worry about copying? If it's show me on your fingers.
Copying?
Copying. Granted, you know, copying, okay, there is an issue, but why is that good in this case? Sure, did you have a hand up, Dawn?
I think it's a way for students
to double check themselves and to answer. And if I get worried about what they really specifically know, I can go about it a different way. But it's reinforcement.
Yeah.
So I'm gonna come back to that in a second, but I mean, if the kid who's copying, do they want to participate? That's a good thing. Talk about, so when Dawn said if you really want to check, she can come back another way, what other mode of response might we use when we really want to find out whether every kid individually knows? Whiteboards, paper, whatever, okay? I mean, so you have that way. You can make that quick assessment with fingers or a choral response or something, and when you really want to know for sure before you move on to the next thing, whiteboards or papers. Other modes of response that you want to talk about? Yeah.
That's Robin.
Robin.
I'm learning.
Well, I noticed you often asked, raise your hand if you agree that ... And so people could just do that, and especially moments where you're trying to pull the information from the audience, that was one that you could use.
When you've just given an answer and the teacher says, how many agree? And all the hands go up. How many people are kind of feeling pretty good right then? Yeah? How many
Wait,
people?
so you just called on me and I just gave an answer, and then what happened?
And I say, how many people agree with that? And all these hands go up. How many people think that makes Deb? How many people have the kid in their room that every time somebody says something right needs to yell out, I had that too? Yeah. So if that becomes, I mean, and that become one of those things that all becomes a throwaway question, but if you can, it's a similar thing to say how many people had the same thing. Now, if that kid doesn't need to shout out, it lets everybody say, yeah, I'm smart too. And so that's one of those things for me. It's positive reinforcement for everybody. The person who said it gets it because their peers agree, and the other people say, yeah, I had it too. You know, but and staying in a good management mode. Management. Not O, it's M.
Well, and on another side, from the teacher point of view, if I called on a kid and they gave a good answer, and I want to make that kid feel really good and say, how many people agree Robin just said a really cool answer, and you guys all raised your hand and you agreed with that. Thank you, Dion. If you guys all raised your hand, then you agreed with Robin, and I knew that was the right answer that I was sort of working the whole day for, and the whole room raises their hand, what does that do for what I'm thinking about what the class knows right now? As opposed to, what if I asked that same question and only one person raised their hand and Robin was right on the, how many people think I'm getting some information about what the class knows, and not totally, but a little bit of information. How many people agree with that? So I'm getting a little feedback. Oh, wait a minute.
I was going to come and stand right by your mic and say
sorry.
that. You're doing a really nice job of asking questions that focus on what the things in MIF stand for.
Oh, thanks. How many people have a sneaking suspicion I should walk over there right now? Okay, what am I going to write, everybody? Nice job. So as teachers, do we do this all the time in our heads? Figure out what management we need, figure out how to get more involvement, figure out how to get feedback, figure out how to focus on the idea we need them to focus. How many people agree that we do that all the time? So sometimes when I'm teaching, I'm realizing, uh-oh, my kids are falling on the floor. I forgot to tell them what I do. I need a management strategy right now, right? And so sometimes using positive reinforcement, oh, thank you for sitting quietly in your seat, right, can help be a management. So that's what we're talking about. Those are the 4 things we're going on in our heads, but we're trying to talk about strategies to do those 4 things.
My friend Tom Lester came up with that acronym, and it kind of came back from a bunch of stuff a lot of us did, but the idea is every issue in your classroom fall into one of those categories? I mean, it's like, you know, and so if you kind of categorize, and so mode of response, do different mode of response sometimes get you more involvement? Do they help with management? Do they get you feedback? I mean, so sometimes there are techniques that fall in one thing, but if you're sitting there and you're thinking, man, do they understand what the heck we're talking about? Then I need what kind of a technique? right? I need a feedback technique, right? I mean, I gotta, if I don't know whether the class understands what I'm talking about, I gotta use some sort of a feedback technique. If I'm sitting there and I only got 1 or 2 hands up, I probably need I might need involvement, or I might need maybe they're just not looking where I want them to look, and I need a focusing technique. But it kind of gives you a way to think about, what do I need right now?
How many people agree that's when it's the hardest challenge, is when right there in that moment we're thinking inside our heads and our kids are all waiting for the next thing, or they're doing whatever else we don't want them to do, and we're thinking right there that that's the part we never get to talk about. So this is what we're trying to talk about, the things, and make it visible, so that then we can talk about that decision-making process, and you can have like little buddies when you go back to your own classroom, and just imagine all of us here, right? We're all on your shoulders, helping you think about what things you need and giving you ideas. So a big PLC we are. Okay, so I got another thing I want to go to in a different place in the lesson, and you can keep thinking about that strategy that we were doing at that point, which of those things it seemed to be helping with. So I'll just get you right back in the context of the lesson. So this is a while before we didn't have the purple ones over here, but we did have the list of, at that point, all the blue ones right there. Those were the ways to go up the 6 stairs. And we had just created that. And then we put all the ways over here without the purple. And these were, what was this? How many stairs is this one? Okay, so that was the 5 stairs list and the 6 stairs list. And then Rick, actually then we ended up, you guys gave him the suggestion to put the ones over here. And then I think he asked the rest of the group. How many people noticed that? He asked the rest of the group what to do over here. Anybody notice that? How many people remember there was one person that came up with the idea over there? And I don't know, it was the one person that shared it. Might have been more of you that said it. But then he turned it back to the rest of the group and asked what to do over here. Okay, and then he had you show on fingers. Oh, was he getting some feedback right there? I gave it away. I'll come up with a better question next time, my bad. All right, so got the 2s, and then he said to you, well, I hate to tell you, but one of those is on that list over there. So I want you to talk at tables. What instruction, well, how many people think that was deliberate? Okay, for what instructional purposes? What did that get us? So talk at your tables about that. You got some ideas out there? How many people heard some ideas about what instructional purpose Rick doing that little section of the lesson might serve? So 1, 2, 3, 4, 5, 6. Oh, it's an epidemic. Awesome. Anybody willing to share? Anybody willing to share some thoughts they heard at their tables? And I'm going to remember that's Karen. Is that correct? Okay, good. Here comes the mic. And you paused even. Thank you, Karen.
We were talking about how when he said that, if you had the conceptual foundation that these were obviously 2s and those were obviously 1s, you would immediately say, no way. But if you were lost and confused and you were like, oh, I better check. So he would know right away whether we had the conceptual foundation of how we had made the 2 lists.
How many people think that was well said? Yeah. How many people think, for those people like me that were busy checking the 2 lists, he asked something right after that to help, because some people were like Karen said and knew right away, right? And I think he teased you guys about, right, about we couldn't see that you had a difference of opinion, right? He and I were talking back and forth, and then pretty soon people started going like this. But before that, I think he asked, how can you tell without even looking? How many people remember he asked that one? Doesn't that seem like a weird thing? How do you tell without, I don't know, I thought it was a weird question. I liked the question, but I thought it was funny that you asked the questions. So how many people think that's a little bit of a nudge for those of us that were actually trying to look, that there's a way to tell without looking, right? So built in both ways. Cool. Were there other things that you talked about as far as that part, that moment? I'm not sharing. Okay, so back in your own classrooms for a second. If you make a deliberate mistake, are you likely to get some kids participating in the silent intellectual protest that don't always participate in other ways? How many people think you might get other kids engaged or involved there? How many people, you could also do what he was doing before about checking for understanding? Okay. So those are two pedagogical instructional strategies. Now I want to think about the math. So at that point of the lesson, if you guys could look up there and mathematically speaking, he was having you really focus on where to be able to answer that question. In those lists, where was he having you focus? If you could tell without looking, where were you looking? the fronts, right? How many people agree that really came to be an important concept in going forward while we're making an argument? So mathematically speaking, that was even a really a focusing technique too. So it was good pedagogically speaking to get check for understanding and involvement, and content-wise, it was what we needed to be able to finish the argument. So all kinds of good reasons. You don't have to only do it for pedagogical reasons. Could be it was a good math reason.
So suppose at whatever, 3rd grade or something like that, I make the problem 3 times 5 is on the board. And I say, you know, everybody knows 3 times 5 is 8. Thank you. Why would I do that? How many people think, one, you check on listening skills. Is that a mistake that kids make? Okay, now, am I going to do that the first time we do 3 times 5? I'm not going to do this until they should know. But if I make that and they catch that mistake, is that helping the kids focus on what that symbol is between those 2 numbers and that it matters? Okay, so you can take those mistakes that kids typically make, and once they should know better, make it and see if they catch it. Okay, do they like to catch you making mistakes? Right? So, I mean, you get all kinds of good stuff going on with that, and they start paying more attention to both what's being said and what's written, and you focus their attention.
How many people think this, when they feel so good, you can say, you can positively reinforce the fact that they caught you making a mistake? How many people think that's a good thing? You can actually make them feel good about that and smart about that. Is it good to make them feel clever? Yeah. How many people think if they're feeling clever, then they're more likely to actually persevere on some problems? Oh, I didn't say that standing for mathematical practice. No, that was just shameful.
Let's see, a little bit more fraction stuff. And this time, I have a hunch that Deb's going to call teacher timeouts, and so we got that cycle going on, and so we'll look at some more fraction stuff. So something that we didn't talk about this morning in the debrief. How many people remember that we kind of left you hanging on that 3 steps thing? One of the things, now, did last time we met with you guys, we did adding fractions with the same denominators, right? How'd you draw out a number line?
2 7s plus 3 7s, if I even recall, right?
We did that? Okay. All right. So one of the things that I have, I'll give you the short version of this. I know a lot of teaching credential programs do something that I really disagree with. They, you know, some of you may have heard this style, and if that's what you heard, whatever. But they say the first thing you do when you walk into class is you tell the kids what you're going to do. You know, you write up the standards on the board and all that stuff. You tell them what you do. And then you do it. And then the last 5 or 10 minutes, you tell them you did it. Right? You know, you say, this is what we did today. Okay.
I went through that teaching program.
Yeah, in my opinion, okay, and this is just my opinion, if you want to make sure kids never think about the subject outside of class, that's what you do. All right? Wrap it up, tie a bow on it at the end before they leave, and they'll never think about it again until they come back. So my claim is this, that I think what you always want to do is leave them with an open question. And at least then there's a chance that they'll think about this outside of class. And the goal is, for me in a class, in all the classes I teach, my goal is that they'll know more when they come back than they did when they left. Because they'll think about something. Okay? So I'm going to model that in a way.
I'm just thinking too, the other thing I learned about when I was in the teaching program was that I was supposed to set the hook for the kids early in the lesson. How many people think what Rick's talking about doing is just setting the hook the day before at the end of the day for the next day's lesson? So it's just a little bit different timing.
So we've done, let's just go back real quickly. This will be, I won't even do this as with kids, pretending this is with kids. Just, I would have done this with kids, so, but if we're doing that, how many people remember what your number line picture looked like? So what did addition mean? Whether it's whole numbers or fractions, what did addition mean? Well, let me back up. What did a number mean? Number was a distance, right? And then addition meant adding those 2 distances together, putting those, so we had that stuff. So if we had this picture that looked like this, something like that. So this first number has to start at, if this is 0 and this is 1, the first thing has to start at, it's got to start at 0, and it goes over to 2. How many people agree that's 2/7? And then our next arrow starts and goes like that. So that's 2/7, and that's 3/7. And so this is 5/7. And how many people think, you know, in a relatively few number of examples, kids would figure out, you add the numerators, they'd see the shortcut and blah, blah, blah. We're good? Okay. Yeah, we're good?
So you're saying we already have that?
Yeah, so we've done that. Now, I want to go back on the reasoning and stuff like that. Can somebody tell me the reasoning in terms of what a fraction is? Why don't you add the numerator? Excuse me, why don't you add the denominators? Yeah.
Because the denominator represents the number of pieces, and you don't double your pieces, you keep the same number of pieces.
So when I talk about the number of pieces in the whole, that also determines the what about the pieces. And how many people agree with that? When you add them together, the size of the pieces doesn't change. Why do you add the numerators? What does the numerator tell you?
Number of pieces.
So how many people think this makes a great deal of sense? Okay. All right, so we've done a bunch of this. Anybody know what question I'm going to try and leave the kids with at the end of the day?
Different denominators.
And anybody know how I'm going to say it instead of different denominators?
Different numbers of pieces.
Yeah. Yeah, so that's going to be my hook for the next time. I'm going to say, well, so I wonder what would happen if we had halves and fourths. So if I did something like that, I don't know if that's the problem. Are the pieces the same size? I'll leave the kids with that. I'll just say, well, I wonder what would happen. I wonder what we could do if that was the case. Okay? So, yeah. So,
cliffhanger.
where did that come from? Anyway, so that's the spirit of this, to try and get the kids to start thinking. All right, so let's talk about this. All right, so we'll back up a little bit. So before I asked that, I would have done this stuff. So let's see. If I had, well, I'm not going to say that.
Just do it, Rick. Just do it.
Yeah, it was going to be that too. So if I had this, stick your hand up if you know what fraction of that line segment is shaded. Everybody, what's the denominator? 4. What's the numerator? 3. How many people agree with that? All right. Now I'm going to try and copy this exact same picture here. How many people can pretend that's exactly the same as that? Now if I'm trying to shade the same amount, tell me when to stop.
Stop.
How many people agree with that? Exactly the same? All right. So what if I did this? How many people think I cut it into more pieces? So, oops, wrong pin. I'm having all kinds of trouble here. I know.
It's buying us think time. That's a sneaky way.
Show me on your fingers how many pieces I cut the hole into here. I know this might be hard. Is this, am I right big enough for the people in the back? It's okay? All right, show me on your fingers how many pieces now? So everybody, the denominator is? 8. And numerator? 4, 6. Let's count them.
1, 2, 3, 4, 5, 6.
So I think if I was doing this with kids, I'd try to do 3 of these, but I'm just going to do 2, so you get the idea. So let's see if because this board's minimal. So if I went and I shaded, I don't know if I shaded that much. Everybody, what fraction? Now I'm going to try and do this same thing again and make the exact same picture down here.
How many people can imagine that's perfect? And it's a copy of the above one. Nice.
So let's say that's perfect. This time, watch, I'm going to really make a challenge for you. Oops, wait a minute, I haven't shaded it yet. I'm going to be a mess by the time this is over. Tell me when to stop if I'm going to shade the same amount. How many people agree that's the same? All right, now this time I'm going to take each of those pieces before and I'm going to cut them into 3 pieces. So this time, how many pieces are in the hole now?
6.
And everybody, how many are shaded? All right, so I'm just, now we're going to fast forward because the board's small. I would probably do this 3 times, all right? And then I'm going to come back and I'm going to say something like this. So let's see. If I said this, green length with colors, how about this?
Green length.
Blue
That says
length.
green length. Blue length.
Is the blue length greater than the green length? Green length greater than the blue length? Well, wait a minute. One of them has. What's true about those 2 lengths, everybody? That's true? All right, now I'm going to say, I should do this like this, huh? You got to admit, that's cool. I could do that over here, too? I'm fast forwarding this a little bit. So let's see. Everybody, what fraction represented the blue length?
3/4.
And what fraction represented the green length?
6/8.
So how many people think those 2 fractions represent the same length? Okay? All right, now let's see. So let's say I've done that 2 or 3 times, and I might do something like this then. So here's this fraction. Let's see. Everybody, what fraction is represented there?
2/3.
I want you, oh boy, now I'm having all kinds of trouble. I want you to just imagine, suppose I took each of those pieces that were thirds and I cut each one into 4 pieces. How many people have a guess what that fraction would be? Take your time out, go ahead.
Sorry, I had to take the mic out of my armpit. Okay, so teacher time. So on the cycle, show me on your fingers where we're at on the cycle. What he just said, that question. Where are we? Are we on 1 where we're guessing, 2 where we're doing it the long way, 3 where we're getting the shortcut? How many people think we've already got the shortcut? Oh, some of you have. How many people think the whole room has the shortcut? Maybe not. What did he just ask us to do?
Remember, these guys are the ones in the morning that said the kids aren't always in the same place. You got to remember, they're different.
That's right. There's different things going on in different places. So he just asked you guys to imagine? So how many people think he's nudging you to get the shortcut right there? Yeah? A nudging question. Imagine, without drawing the whole picture, what it's going to be. And would you think he might be, I could see if somebody said that he's asking you to predict too. Did anybody else think that? He's asking you to predict with that question? I could see a justification for that if you thought that. That makes sense to me. All right. Unteacher timeout.
Okay, so what I would do probably with kids, and we'll get there, we'll go back, I'd ask, I'd have them take guesses. Then you know what I'd probably do next? What's the long way? Yeah, I draw a picture on your paper, chop each of those pieces into 5 and see what fraction it comes out to be. No, you don't have to do it, all right, but that's what I'd probably do with kids. I have to, depending on the grade level and the whatever, you know, fine motor skills and all that, what pictures they could draw and stuff like that. But I mean, you know, so let's see. So if we do this, if we chop each of these into 5 pieces, how many pieces are now in the hole? How many, everybody? 12? I had the wrong number. Oh, because I changed the number, huh? No,
I didn't get my mic on fast enough. Sorry.
I'm having trouble in my head here. So let's see, I cut each of these pieces into how many? 5. So how many are in there now? 15. And how many are shaded?
They're so good, they had either answer for you.
Yeah. So as I progressed down the road with kids, and I said, so how many people can imagine a picture for 3/10? People can imagine a picture. Suppose I took that and I cut each of those pieces. How many pieces in the whole? And how many are shaded?
3.
Suppose I took each of those 10 pieces and cut each one into 4. How many people know what the denominator would be now? Can somebody tell me, what do we hope the kids are going to say?
40.
By the way, are the kids, well, let me ask a different question, then I'll ask that one. If you asked how they know there's 40 or why there's 40, what would you like to hear a kid say? Talk in your groups. What would just, like right now, you know, you're doing this stuff, you're doing this class, and you say, can somebody explain to me why, in the context of the picture, why it's 40? What would a kid say that would just make you just jump up and down and smile? Your inner teacher self would be just, oh, give me a raise. What would you like to hear those kids say? What would you love to hear a kid say for why 40? Anybody hear something at their table that they really liked, or have something that they said themselves that they're just so impressed with they want to repeat? Somebody. Yeah, I knew that. Did it? It's over there.
Oh, hi. 10 times 4.
How many people like 10 times 4? You'd like to hear that? How come? Why 10 times 4?
You guys can raise your hand and say it for her.
I think you're supposed to.
Well, I was waiting for her hand to go up. I can't let other people volunteer.
10 groups of 4.
How many people like that 10 groups of 4? Before, the whole was cut into how many pieces? And each of those pieces became? So how many people think we're looking at 10 groups of 4? How many people see a parallel for what's going on with this 3? What does this 3 represent, everybody or anybody? And what's happening to each of those pieces? It's cut into, so is how many people think we know something about equivalent fractions now? We okay? Yeah.
So when he had you guys talk at tables, I'm trying to remember what the question was. I know where we were on the cycle. Maybe you guys know what the question was? Or do you know where we were on the cycle? Either one. What was that? Anybody remember? What was that last question we just talked about at tables? Anybody remember? Oh, since I'm over here and there's someone over here willing to say it, are you willing to say it from the microwave? Thanks. In the microwave.
What would you be thrilled or excited to have your kids say about this?
Right? And you guys got that? So where was that on the cycle? Because I don't see anything over there about what would you be thrilled about. It doesn't say that. How many people think when Deanna answered and she said 10 times 4, the kid is saying the shortcut? And then when, oh, it was somebody over here. Oh, yeah. Erica answered and said 10 groups of 4. She was somewhere else in the cycle. When she said 10 groups of 4, she was moving up towards what? Why it works, right? So we had both. And how many people think we want both in Common Core? We want both the shortcut and the, right? So that's why we would be jumping up and down and thrilled, as you said. Okay.
So,
I have a different thing.
Go ahead.
Okay, so you guys remember the problem 3/10 and Rick had us imagine it in our heads? How many people think we're going to want to have feedback from the kids to see if they're ready for that particular question? Because if I ask that question too soon and they don't get this, I'm going to be doing a lot of what on the board? And in this case, do I have to make a picture of that? Do I want to draw 40ths? Right? So you have to, so when you start thinking about what's your path for how you're going to get kids to figure out, that's the kind of question you want to worry about on imagining. And if they balk right there, then you probably want to back up and ask them something drawable, right? Drawable.
Drawable, yeah. Yeah, I mean, this is one of the hard things for all of us about professional development is we're trying to go through this like with kids, but I mean, I would be getting a lot of feedback from the kids on each of those steps, how they were doing, and that tells me whether I want to do more examples or we're ready to move on. Okay. So let's see. Okay. So we've done that stuff, and how many people remember where we're heading? What's that? What was that question I left for the kids? 1/2 left. Okay, so we're heading there. So something I would probably, if I was doing this, I would probably have this someplace where I could leave a piece of paper up in the room or something like that. But let's see if I started, if I started with halves. That means I cut the whole into how many pieces? 2. What would happen if I cut each of those pieces into 2 pieces? What would my denominator be now, everybody? 4. And what if I took each of these 2 pieces and cut each piece into 3 pieces? Then what would my denominator be? 6. And what if I cut them into 4 pieces? 8. How many people are seeing something going on there? Well, what if my denominator was 3 and I cut each of those into 2 pieces? Then I'd have what denominator? 6. If I cut each one into 3 pieces? 9. And so I get this list on the board and I do it for fourths. So I'm going to call these maybe like families of fractions. Something like that.
You want me to put it over here for you?
I don't care.
So committal.
All right. So I might have something like that we've done. So can you see the kids getting from there to recognize these families that you could? Okay. All right. So now I must confess I'm fairly shameless at times. So done a bunch of this before, and I come back the next day. Well, let's take a look at this problem that we were looking at yesterday. Now take a quiet hand. What's the problem with that? What's the problem with that? Can anybody tell me what the problem is with that? Yeah, way back.
The sizes are different.
How many people think I liked hearing that? Well, how many people think that's a problem, that the size of the pieces is different? Anybody have an idea what we could do to make the size of the pieces the same? How many people have an idea? I didn't ask a question, did I? How many people have an idea where I'm standing where I am? How many people think if I walk and stand by wherever this, remember that I left it somewhere? How many people, if I leave it somewhere, some kid's going to say, hey, wait a minute, you could. What can you do? Does anybody have an idea how, could we make the pieces the same size? Can we make fourths halves? Can we make halves fourths? How many people, oh wait, can we turn halves into fourths? What do I have to do to all these pieces to make fourths? Make how many pieces out of each one? 2. So if I do this, if I cut each of these pieces into 2 equal pieces, how many pieces in the whole now? 4. And this one piece becomes how many? 2. How many people think the pieces are now the same size? Very nice. And everybody, 2 plus 1 is? 3. And 4 plus 4 is? 4 plus 4 is? 4. Wait a minute, why don't you add the denominators?
Adding the size.
Oh, thank you. Because what?
Don't change your...
What's true about? How many people agree the pieces are the same size? Should I tell you a good story about, like, way back at the beginning of my teaching career, why a kid told me you don't add the denominators? Because this is before I started thinking about reasons why and all that stuff.
So a story timeout?
Yeah, you want to hear this?
Yeah.
This is really cool. So I made that mistake, and this kid disagreed. And I said, what's wrong? And he said, Mr. West, look, it's math, right? And I said, yeah. And he says, it's math, so you always start on top? Right? You always start on top. What's 2 plus 1? It's 3, right? And he says, now look, you used up the plus. That was his explanation. So I didn't talk about multiplication of fractions for a long time, but So, all right. Teacher timeout.
Can I call a timeout about something that happened when you were standing over here?
Yes.
Cool. So I don't know if you guys remember this. A little while ago, he was just teasing us and asking you all as teachers how many people had an idea why he was standing here, and you guys giggled. Yeah? Okay. And then he asked how many people have an idea of what I can do, and he didn't get very many hands. And then he asked a question to which he got some hands. I would call that a nudging question, or a flashlight question, or a guiding question, or whatever kind of question. How many people need these kind of questions in their back pockets for when you get no hands? Right? This is the sort of thing you want to figure out. What's the thing to shine the flashlight on? Let's see, I'm trying to remember what it was. I think he said, then a little bit more specifically, how many people think I could turn halves into fourths? How many people agree that was a little bit more of a flashlight, a little step, right? And so then you were looking, and maybe we didn't need it and you saw it, but from the feedback he was getting, that was what he was looking to do. So those are the little things I'm watching for when I'm trying to figure out what were those little questions that help shine a light so that they can make the next leap. That's what we're going to be creating when you guys do your own topics. Those little things. Okay, cool. Unteacher timeout.
So I'll teach your timeout myself here too. So I think a lot about the culture that I want to create in my classrooms. And one of the cultures I want to create is that when I ask kids a question, they always know that there's enough, there's information, they know enough to figure it out. Okay, because I don't want them waiting for what?
Mm-hmm.
I want to create the culture where they don't need me to tell them. All right? So one of the things, and I mean, I've done this with little kids, and I've done it in my college class. I actually told my college class, because I was disgusted that they didn't know how to do it. I always said this in a polite way, but I told them what the little kids did. All right? And then they figured it out, because I was telling the story about what little, because I'd done some problem over here, and they weren't sure what to do next. I was asking them questions, so I told them the story about the little kids. That the little kids know that when I'll say something's a random question, they know it's not random. And so what they do, if I'm asking a question, well, here's a random problem, the first thing they do is they look over there. Because they know that that's a hint they've gotten the cultures. They know this has something to do with what he did a little bit ago. So look over there. And I was telling this story to my college class because there was something over there. They needed to do this problem. And finally, this one really shy kid started laughing. But she wouldn't raise her hand. I finally said, is something funny? And she goes, and she looked over there and goes, yeah. And then everybody else looked over there and saw that. But so the idea is this. I'm sorry if this is a little long-winded. I want kids, when they get a question that they don't know how to do, instead of waiting for the teacher to tell them, to look around. Look around the room to see what else you know, or look in your brain to see what you know. And trust that essentially what the culture that happens in the room, if Rick, what Mr. West, whatever they're calling me, if I ask a question, they know that there's enough information out there somewhere that they already know in order to answer that question. So that's what they're thinking. If he asked this question, I must be able to figure it out. Look around, see if you can do it. That's the culture I want in my room. It's different in the cultures than the rooms that I grew up. So,
how many people think that would be cool if we could build that same culture in our own classrooms, right? So that's what we're trying to take apart and figure out how to do. Look at my own brain. I like that one.
it's not a switch you flip, you know, I mean, over time. All right, so let's see. If I had, so we did that one. What if I had, I don't know, 2/3 plus 5/6? Are the pieces the same size? How many people know which one you could change to make the pieces the same size? How many people would change the 6ths to 3rds? How many people would change the 6ths to 3rds? Oh, how many people would change the 3rds to 5ths? I'll get this right eventually. How many people would change the 3rds to 6ths? I might be drawing pictures, you know, I get the feedback from the class. How many pieces do you have to cut each of these into to make 6 pieces in the whole? Show me on your fingers. So if I do that, and there's now 6 pieces in the whole, this 2 pieces becomes how many pieces, everybody? How many people think now the pieces are the same size? So everybody, the answer would be? And if I do, and you could decide whether, at this stage of where you were, whether you want to write that as 1.5 or not. Whatever. All right, so and I'd pick some other ones, like, so let's say I said 3/4 plus 3/20. Are the pieces the same size? Which one are you going to change? Hey, wait. There's something I can talk to you about at some point, but sometimes I do differently. Did anybody notice anything about which one you always change? Do you change the bigger pieces to smaller ones or the smaller one to bigger ones? How many people have picked the smaller pieces or bigger pieces and change them? Is that what you do when you compare like quarts to gallons? How many change the gallons to quarts?
Oh, they must change quarts to gallons then.
Maybe, I don't know, anyway. All right, so let's see.
I'm thinking they go a fourth.
We could change fourths to 20ths. How many pieces do you have to cut these into? Which would make 20 pieces in the whole. How many pieces will that be? 15. And so how many people think that works? Okay, teacher, timeout.
When I learned how to add fractions, my teacher did not say those words that Rick just said. I was like, okay, we got to get the common denominator. What do we got to multiply this by? What are both numbers going to go in, right? Because he wasn't saying those words. How many people agree he's still working on trying to get the kids to get the shortcut before he starts calling it that official vocabulary? Okay. Is what he's saying, when the kids are doing this, what are they conjuring up in their heads probably when he said, are we going to change the fourths to 20th or the 20th to fourths? What do they think about in their heads? How many people they're thinking about number line pictures? And so he was using the language of number line pictures all the way through there, trying to get them to be able to grab a hold of that until we get to the place where we can start talking math only. He's living in the context. Well, it looks like math only, but he's living in the context in what he says. Okay, unteacher timeout.
Yeah, I'm living in the context of what a fraction is. Okay, and to me that's the contextualization here. It's not just the algorithm, not magic tricks with numbers, but it's living in the context of the definition of fractions. I claim this, and I know, I apologize, I mean, we're using fractions as a vehicle to demonstrate your particular curriculum. I know some of you don't teach fractions, but keep in mind, we're not saying kindergarten through 6, you should just teach fractions. Forget whatever, but this is just to give you an idea of what we're talking about. But the context here is that the numbers just never become, numbers that don't mean anything. They're always in the context. I claim this: if you're teaching fractions, you cannot refer to the denominator as telling you the size of the pieces too many times. It's impossible to refer to it too many times. Keep going back there. Okay, so one more thing and then we'll see. So we're getting close. So what if I said this? What if I said 3/4 plus 2/3? Are the pieces the same size? Oh, well let's, and oh, you told me before, which pieces are smaller? Well, then let's change the fourths into thirds. How many people think you can't change fourths into thirds? Well, then how about thirds into fourths? Teaching's hard work. I mean, sometimes I get really tired. Does anybody have an idea what we might do? How many people see something that's in both the thirds family and the fourths family? What is it, everybody? So let's see. If I want to turn these into 12s, how many pieces do I have to cut each of these into? 3. Which means they're how many pieces? 9. And I have to cut each of these into? 4. Which means these 2 pieces become? 8. How many people think we just successfully made the pieces the same size? And so you could add them? Okay.
Cool.
I guess the only thing, I'm going to quit with that. I want to say this, because I think I gave my spiel about don't feel like you have to reinvent everything you do and make it look like that. Did I talk about that last Tuesday? I really strongly believe that in professional development, one of the big things is that you guys as teachers, me too, have you ever noticed this? Are there any administrators in the room?
Probably.
Oh, there's Carrie. Close your ears. Have you ever noticed this, that administrators or people even, you know, kind of higher up administrators, they're really, really, really good at addition but not at subtraction? Have you noticed that? I mean, they're always good at the add stuff. Teach this, but they never take anything off your table, too. All right? And so, personally, I don't want Common Core to be that. Okay? Common Core, if you're going to teach this stuff for understanding, if you're going to get kids to figure out the algorithms themselves and you can get them to understand why, this is going to take a lot of work, and it's not going to happen. This is the spiel I thought I gave, you know, last Tuesday. It's not going to happen over the next 2 years. It's going to happen gradually over a bunch of years. And I think your PLCs are a place where you can, you know, pool your resources, and you have people like those of us in the room that you can ask that question. But what led me to think about this is I want to say this is how I really started thinking about teaching fractions in the last 5 or 6 years. And I've been doing professional development for a long time. You want to hear what I used to believe? I used to strongly believe that you could not teach addition of fractions until you taught multiplication. All right? Because in effect, the way I used to do this is how did you get from here to here? Multiply by
3.
So if you multiply by 3/3, which is 1, and now you know that's that. All right? That's what I used to believe you had to do. But then I had this revelation. First of all, were we able to take this picture of 3/4 and chop it up and to get that it was the same thing as that? Were we able to do that without multiplying by 1? Right? Now, when you did that, so there were 2 pieces in my sort of evolution of thinking about this. One is, do you have to be able to multiply fractions to get that? Okay, so that was the first thing. No, you don't. You don't have to. The second thing was this. When I do it this way, am I forcing, there's a bunch of the second thing. There's part A, B, and C. Am I forcing kids, or am I getting kids to live in the definition of a fraction longer by doing it this way than by multiplying by 3/3? Okay, this is more based strictly definition. But then here's the kicker for me. Now later on, after they've done a bunch of this and they're good at this, and then we learn multiplication, then I can go, hey, wait a minute. You remember when we did this? Well, what would you be multiplying that by if you got that? What fraction? Hey, but we already decided 3/3 is what? 1. And what's 1 times 3/4? 3/4. So now, I hope I can make this make sense. They've seen it one way, and now it comes back and matches what they see has to be true about multiplication. And then they're thinking, hey, we got the same, I like to joke with my college classes, we've got the same answer 2 different ways, must be math. It ain't I before E except after C and all that stuff. Okay? So I think this is a way to kind of emphasize for the kids, hey, this is pretty cool. Remember how we did it one way, and now we go back and look at it this way, and it has to be the same thing. So they see that math anyway. That just, that appeals to me.
And it's nice to have more than one way.
Yes.
So I have another thing about more than one way. So what I like to do is, first I want to find out from you guys, while you're sitting with your school groups, how many people have a grade level buddy at their school group? Yeah, that's what I was thinking, not too many. Because you're like, right, okay, 1, 2, 3, 4, 5 at the table, right? Okay, so that's good. So in a little bit, I'm going to ask you when you want to move. At some point here shortly, it's going to probably be beneficial to you all to be sitting with somebody that is grade alike. And I have something to do right before you're going to have your planning time, but not too long. So my question is, would you rather move now or in about 15 minutes? How many people would rather move now? How many people would rather move in 15 minutes? All right, then, that's fine. Okay. So you have a warning that I'll move you in about 15 minutes. Nah, I'll be good for now, and we'll switch when I send them to groups on a task. So what if all of our jobs was to plan a lesson, and we're going to try on the cycle, and what we're trying to get kids to know how to do is this. Am I on the screen? Yay. Am I really? I like you, though. I'm trying to get them to do that. First thing to think about, just quietly to yourself in your head, and then I'll have you tell your neighbor in about 15 seconds, what's the shortcut that I'm going for, right? What's the shortcut? Okay, go ahead and tell your neighbor. Okay, for most people, I overheard because you did a good job of sharing with the neighbor, and I was able to eavesdrop, and I heard add 2 zeros. How many people would append 2 zeros to the end of whatever number you're multiplying by? Okay, that's what we want them to do, yeah? If it's a whole number. How many people agree with that too? Okay, will probably be the first place we start, and then maybe we do decimals later. All right, so that's the shortcut. So that's your first, as you're going through the cycle for planning, that's the first thing you want to do is figure out your shortcut. So here's what I want you and your table mates to do. Is I want you to figure out, because your second thing on the cycle is you're supposed to get the kids to be doing this the long way based on previous concepts. So in about, I don't know, 3 or 4 minutes, maybe not even that long, that might even be only 2 minutes, see if you can come up with what's a long way. So say I was going to give them these problems, 8 times 1, 8 times 10, 8 times 100. I'll already identify the tasks, okay? Now you guys come up with what would be a long way to go about it. How many people think there's probably not too much of a long way on 8 times 1? All right, so probably the long way you're talking about is right there on 8 times 100. All right, so what's the long way you would have the kids doing it before they figure out the shortcut? You got 2 minutes to agree on a long way to go at it. So how many people had a variety of possible long ways out there, even at your tables? Interesting. What you can't see on this Post-it note says, oh, I might have to have you guys help me here. That might be good.
Or a piece of tape.
Did I get the right number? How many people agree that would be a long way? Okay. Anybody have another long way that there was a different one that they suggested at their groups? Yes.
Number line.
How many people think you could have them run out to the number line? If you're doing number line, I'm guessing there might be a parallel here. I'm sort of guessing you might do a number line counting by hundreds. I don't, right? So that would be a decision. Yes, sir?
I did it with squares, 8 by 1, count the squares, 8 by 10, and then the really long way, count to 100 square.
Oh, so I'm not doing a very good picture.
No, that's okay.
You're talking a little, like base 10 blocks, right? And then this one, they do a shortcut, right? They call the rods or whatever, right? And they just draw out lines. Okay, how many people agree that would be another long way? Okay. I thought I heard when I first walked around, somebody say, we'll just do the algorithm. 8 times 0 is 0, 8 times 0 is 0, 8 times 1 is 8. So there's 3. So how many people agree there's 3 potential long ways? Now the question is, which are previous concepts for my children? So that's what you have to, so various people at your tables when you're doing this, your kids may know different stuff. So you have to decide what's previous for my kids. All right, so once you get that decided, then try and figure out how are you going to get the kids to figure out the shortcut. Now, I stole an idea from you because I just suggested, what if I was going to do that, that, and that? If you're planning this yourself, maybe you decide, hey, Deb, I don't want to put up 8 times 1 and 8 times 10 and 8 times 100. I'm just going to only multiply a whole bunch of things by 100. That's up to you, right? You figure out what tasks would help your kids figure it out and what you're going to do in order to get them to get the shortcut. So now I'm going to send you back to groups. I'm going to, Rick.
That's real quick. How many people have kids in the room who would, on those long ways, somebody would say, you don't have to do all that, the answer's just going to be this, right? I always like to ask teachers, how many people in the current classroom already know who that kid is?
Could you, as a teacher, if that kid was absent that day, say, man, I'm tired of doing all this work. I wish we could come up with a shorter way to do it. How many people think you could do that if you wanted to expand the number of people, right? Okay.
So this culture thing. The other thing that I'm trying to do with that guess is I want to create I don't have kids guess at something if they have no way of knowing the answer. Okay, I don't have kids guess at that. I want the culture created when I ask kids to guess on something that they know as soon as I say that there's going to be a shortcut, right? That's what I want. That's what I want kids knowing. As soon as they hear the word guess, there's gonna be a shortcut. I know the cycle. They don't say that part, okay? But if they get that, if they know that in the culture, they're gonna probably see the shortcut faster than if they don't know there is one, right? That's what I want. I want them looking. I want them.
Okay, so as you're planning, we got the shortcut identified. We've brainstormed some different ways to go at it, long ways. We know that we're going to probably lead off whatever our tasks are, if you don't like mine, with let's guess what this one would be, so that we can kind of get them the idea there is a shortcut in existence. And so then, say we got the kids to identify what the shortcut was with all those choices. What's the next thing on our plates after? Do we just stop after we get the shortcut? That's kind of what we used to do, right? Okay, so then we got to come up with, all right, so how do you know it's always going to work based on the same sort of previous concepts? Can you ask them a big giant number here or something, or I don't, right? So how do you get them to actually answer the question? Why should that work, that you just stick 2 zeros on the end of any number that you're multiplying by 100? So why don't you talk at your tables now? What answer would you like to hear in response to that question about that would justify why that works? It may change based on whatever previous concept you chose, but what answer would you like to hear kids say about why is that we just put 2 zeros on the end of that? That's kind of hard, huh? Yeah, so talk at your tables, see if you can come up with a good way to, why is that? That's what we're shooting for. And how will we get the kids to figure that out?
Most of the time.
So why does this work? I've been doing it so long. It's like tying my shoes. I don't know how to teach anybody else to tie my shoes because I don't have little guys at home. I don't even have laces. I'm in trouble. So why does it work when you, anybody come up with a way to explain why this works? They want to share? Did anybody's definition go along or explanation tie into place value anywhere? Okay. Was your hand up? Yeah. Okay. And that's not Bill, that's Deanne again.
Yeah, well, it's Bill's answer.
That's nice, Deanne.
We were talking about how it is just built on the base 10 model. So if you look at 100, it's actually made up of 10 times 10, which, again, you can go to exponents, and it's 10 to the second power, and that's kind of showing you how many zeros, those 2 zeros.
How many people have something to do with that? Where do you write numbers when they are indicating how many powers of 10 that they are? I need a better question. My bad. In the air. Can you read what I'm writing? Ones, tens, hundreds, right? Thousands. So if I'm trying to say I have 800s, where do I put the 8? If I suddenly move the chart and the chart's no longer there, does that still look like 800s? How many people think that's kind of what's going on here, right? No matter which long way you do it, we're trying to get at that. The only way to indicate that that's 800s is if I have, that's the whole notion of the zero action, right? We just went boom all the way wherever they do that. Thank you, kindergarten and primary teachers, right? Yeah. Okay. So now is the point. And Rick, yes.
I think there's something hard about this thing right here. Can you put a 1 in front of that 800?
This one right here?
Yeah. How many hundreds is that?
18.
Is that what your kids would answer? Yeah, I mean, it depends on the kid. But I mean, I think it's really obvious from a repeated addition or a place value thing that 8 times 100, you put 2 zeros behind it. Okay? But I don't think it's as obvious when you do 18 times 100. And so I think if you want the kids to understand why, they have to know that that number is 18 100. How many 100s is that? So to me, there's a difference between these two questions. What number is in the hundreds place? How many 100s is that? And I think if you want kids to really understand that putting 2 zeros, they have to understand that that's 8. They have to see that there's 18 100s in that. Okay.
So I don't know what standard this is, but it's not first or the multiply by 100 business. How many people agree that's a intermediate, right? That's 4 or 5 or 6 or somewhere in there, right? But there's a lot of stuff that has to place value understanding that comes into play when you're really trying to make sense of that. So we got to get together and work with each other here. Okay, so I'm going to structure this first part, but this is a sort of conversation that we're going to make our own little ancillary PLCs. You guys have your own PLCs at school, right? But we're almost our own little PLC group right here. So we're going to ask that you guys choose something that, if it could be coming up in the next week before we see you again, that'd be cool. Because what we'd love to hear is, okay, so we planned this lesson that we'd go try, and a couple of us were able to go try it with our kids, and then you can come back and say, yeah, this question worked. That one question that we figured out, that one worked for me. And when I got to this place, I just needed another question. I didn't know what it was. Oh, but who are you going to ask when you're not sure? How many people think that's what we're building right here, is we're building a group of folks that are trying to figure out good questions to ask, right? Okay, so that could be what you could bring back. So your first task, and you only have 2 minutes to do this. Wait, let me ask, I'll back up a minute. How many people have been to a planning meeting before when it took you 2 hours to figure out what you were going to plan? Has anybody done? Oh, not all of you. That's good. I have been to one of those meetings, and it's just kind of painful sometimes. So has anybody else ever had that happen where you're trying to talk in a group and it's hard to make progress just because there's so many people and so many ideas? So you may think about that as you begin talking. You may, are there strategies that you can use with each other to just sort of, keep yourselves on the task at hand? We're trying to give you some time to actually apply the cycle to something that you got to do next week. So hopefully, or the rest of this week, but maybe that can't happen and it's got to be later. Are you guys okay with me putting things up right here? All right. So first thing you got to figure out is, what topic are you doing? What shortcut are you going after? That's the thing that the first thing that you have 2 minutes to decide, because I don't want to spend all that. I got to move it down. I have buddies right here. I bet you she'd move it down for me. Look at that. Thank you. So you got 2 minutes. What shortcut do you want to do? What topic? I realized a couple things that I didn't say before I sent you to groups. How many people have ever done that before? You send everybody out to groups and then you realize a couple other things you might have should have said? Sorry, my bad. So one thing was, I didn't say that if you had 8 people sitting there, all 8 of you don't have to agree on one thing. It could just be that you and one other person are planning this. So that was one thing. So how many people already splintered up groups anyhow? Okay, good. I'm so glad you figured that out. Yay. Another thing, not every single lesson is something that you can apply the cycle to. Only those lessons where there's actually a procedure or a shortcut that's the point of the lesson, does this actually make sense? So not every single lesson is like that. And so you want to kind of pick one where there is a shortcut that exists. So kids could be looking and trying to figure something out. So that's something I wish I had said a minute ago. Any other things that Carrie and Rick are you noticing out you wished I'd have said a minute ago at this point? I have seen a few. I've seen some good conversations. How many people have been wrestling with the different long ways to go about doing whatever it was that you were doing? Okay. Anybody else been trying to nudge themselves on trying to figure out, well, okay, so for the kids that aren't getting the shortcut, what can we do to shine a light so that they kind of ask a guiding question? Anybody talking about that? Okay, less people talking about that. Cool. Maybe you have some ideas about that. That's good. Are there any other things that you're looking for, points of clarification or thoughts or ideas at this point that I can do for you? Rick.
I just kind of had this thought that, well, first of all, how many people think this is hard? This is hard. It's been hard for me over the years. I've been doing this for a long time. My bag of tricks is getting bigger. All right? But I think one of the reasons why it's hard. Microphone. Oh, yeah, microphone. Thank you. Did he tell you to say that? No. Well, one of the reasons why this is hard is because what I was used to early in my teaching career, this isn't really true actually, but I have to tell you that I'm going to lie in a second, but one of the things that I got lucky to do when I was an undergraduate in college, I signed up for this deal where you went in to teach elementary school, and we didn't know a lot about how to do this, but the rule was you had to ask questions. That's all you could do. Couldn't tell them anything. You just had to ask questions. All right? So there was a lot of fumbling around. But anyway, this program, they had a lot of really smart people, and so people looked and said, well, that works, that doesn't work, that worked, you know, and we came up with a lot of this myth stuff and all this other stuff. But anyway, so if you pretend that I didn't do that, right, so I'll lie to you. Early in my teaching career, I taught by telling kids how to do stuff, right? And even there is some truth in that, because early in my teaching career, until I'd figure out what question to ask, I had to tell kids what to do. Well, you know what? You don't have to make any sense if you're telling kids what to do. All you have to do is tell them the directions. Just, you know, fractions, see those numbers up there, add them together, keep those the same. And so what happens is, I think when we force you into this issue of how you're going to get kids to figure this out themselves, you have to think about how are you going to script and exactly what problems you're going to put in front of the kids so it shines that flashlight on exactly what's happening. Okay? I was talking to one group, and I'll just use this as an example. Why does, I don't know, why is that a good choice of a fairly early long division problem? There's no remainder? Anything else? Right? If you think about this in terms of fair share, what does this represent? Can you fair share 4 100s among 2 kids? Each kid gets how many? This represents what? Can you fair share, represent 8 what? 10s. Can you fair share 8 10s among 2 kids? Each kid gets, and so on. Okay. So as you look at this, I mean, I could teach long division and just do a bunch of examples and tell them how to do it and stuff like that. But the challenge in getting kids to figure out for themselves is what problems do you choose that get rid of all the noise, you know, and other ways that kids could figure out and just say, well, then, that's how you're doing that. And this is difficult. But what I'm seeing as I walk around the room is I think people are starting to get a sense of you know, I guess this is what I want to say, is I think people are starting to get a sense of this over here, yeah, that doesn't look like that. This over here, that does look like that. And to tell you, that's the first step too. You have to recognize that your book, and most books, in my opinion, they do this thing, they just, here's a bunch of stuff that doesn't really make sense. You're not really, you're just teaching kids to get an answer. And making that distinction between the two, that's the first thing that has to happen. If you're there already, this is good. Right? So now then you have to start thinking about, okay, well, what makes sense and what problems do I put in front of the kids to get them to see this logically?
I got an idea.
I like ideas.
I'm going to act something out, and I want you guys to, let's see, what mode of response. I'll just have you go when I get to the place where I quit doing the cycle. Okay? So I'm back to my multiply by 100 thing.
You want to practice once first?
Sure, you can practice once. Ready, go. All right, here you go. Oh, you're even kind to me. I won't even be scared when you do that at me. All right. A while ago, I was saying, all right, kids, here's your warm-up. I want you to do that, and I want you to do that, and I want you to do that. How many people agree you already did that? All right. And so somebody told me that one, and somebody told me that one, and somebody told me that one. Great. So now, kids, what I want you to do next is I want you to do this problem. How many teachers out there knew that problem was coming? All right. So the kids start doing this. Am I on the screen? No. Now am I? Yeah. Thanks. Oh, thank you. One of these days I'll get a pen that writes, right? How many people think me as a teacher, I was not very excited? So then I did this. No, see, guys? You got 1 here times 8, that's 8. And then you got that thing right there, that 0 right there, and there's 1 0 right there. See, guys? And then there's 2 zeros right there, and then 2 0. I hear some How many people think I just biffed on the cycle right there? So that's what I'm trying to prevent. I don't know if any of you are old enough like me. Do you remember this noise? Wah, 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 wah. When I start doing that, that's what I hear in my head as a teacher. I hear Charlie Brown's teacher going in the background, and I went, oh, my goodness, I just didn't want to go there, but I did. So then I figure out what I'm going to do about it. Oh, I'm going to bring it to my PLC buddies, and I realize I need another question. My kids didn't notice what I wanted to show them, so I need a question right after this. But before I give them this, something that's going to help nudge them along to figuring that out. So that's what I need is I need a question to ask instead of see. So if you get to the place where you're talking in your lesson and you're thinking, oh, let's hope they notice, or you're probably to a place where you want a question. So that might be what you talk about next. If there's a little sticky spot that you're thinking, you could be talking about, how am I going to get them to notice the shortcut? What little thing could I do to help shine the flashlight and focus them on that thing I'm trying to get them to notice? Okay, so try and avoid that. Don't kill yourself if you do it. I do it all the time, right? I just put another thing on my list of things that are yet to come. Yeah, Rick.
Don't be afraid to make that flashlight like a laser beam. All right? So the example that just did, I think you can stay in character and say, whoa, well that's weird. That's when I multiplied by 10, I got how many zeros on the end? Everybody? When I multiplied by 100, I got 2. That's weird. I wonder what happens when you multiply by 1,000.
How many people think that would do it and would save me from going, see? Right? So that's the thing, we're having PLC buddies so we can come up with that little sequence.
That's what I call a hard spin.
Really flashlight, laser beam, huh?
I mean, you're really, really, but I mean, the kids still eventually, they're the ones who say, oh, I see what happens.
Okay, so give you some more time. So if you got to a place where you kind of agreed, I don't know where your process is. If you feel like, okay, I think I got to know how to do that, pick another one if you're to that place. Now, I wouldn't imagine most of you are there, but I just thought I'd toss that out there. So make this use of time productive for you. We're going to give you about 20 more minutes in this. So yeah, knock another one off if you already got that one done. So I'm going to get some feedback from you guys in 2 ways. One, the typical normal feedback form, but the other one, I'm going to have you do a little writing of reflection prompt. But we've been talking about this for a long time today. We started off the day not even having you guys doing planning out of your Go Math, right? But we were trying to construct the day so we were setting up this moment. So one of the things I'm going to have you write about, so we did the problem solving because it was supposed to shed light on what was supposed to be happening right here during this planning time. How many people remember that we were trying to have you do it as learners for yourselves to feel what that feels like from the morning time, right? So, and then we started talking about fractions for a long time and how the cycle could be applied to that. And we did that before and after lunch. And then we finally got to the place where you were able to go, okay, so let's look at something that we think we might be able to apply that and get together with people that are at similar grade levels and start trying to think about how could we get the kids to figure that out. So one of the questions is going to ask you, is there anything else that we can do over the course of the day that would help you at this point in time? Because this is what we want to, where the rubber meets the road, where you're going to go try something with your kids. Is there something else that we can structure during the day that would make this time be more effective? And this will get written down for you too. Or less time consuming, because this is the part. So that would be one of the questions. And the other question will be to have you think about what are some things that you're taking away from here as a teacher, some thoughts about, oh, I might go try this. Or it could be one thing, or it could be a couple. So a couple things some takeaways. So how many people at least have one idea in one of those 2 realms already, a little bit? Okay, good. So Carrie's writing this down, which is good, because you've seen my handwriting, right? So she's writing that down. I'm going to be finding paper. And so the other way we're going to get some feedback from you is on the Scantron feedback forms, which all the people from Elk Grove that have those. Oh, no, they're right there. So we're going to be bringing those around. So there's 2 things you're going to do. You're going to write on a piece of paper the prompts that Carrie's putting up here that I just said. And I'm going to bring you the paper. And you're going to be filling out the Scantron form.